those that walks the line. There's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a great, to a duel.
Hello everyone, my name is Old Man Builds, otherwise known as Nathan, and I'm here with Joe, otherwise known as Straight 8 Dope, and I'm also here with Gerald, and we're going to talk a little bit of physics today, and we're going to start with the conservation of energy. So, a couple things right off the bat and what we're working with and where we're actually going to go from here. They always talk about the conservation of energy as the golden rule for anything that has over unity. However, can you create a system that actually pertains to the rules of conservation of energy in a way, but then breaks them because of the thing that you created with the original system? So, one way to understand this, okay, is through Gerald's coil. Okay, he's doing that right now. I'm going to give you a real simple way, okay? All I'm going to do is take a Tesla coil, and I'm going to describe it like this. When I have my Tesla coil, am I following the conservation of energy? Sure, you could say I am, okay? My system will absolutely use energy in order to create the coil and oscillation at a DC frequency, right? Nobody's going to argue that, okay? What am I going to use? Am I going to use the hot side on that energy and light up light bulbs, okay? What if I don't want to use that side? What if I want to use the side in the center? Now, in the center, when I put a wire down it, what happens? I get cold energy. Now, this system works fine. You're using a little bit of energy. You're getting the oscillation. I'm creating a pump. Now, there are some caveats to this, which will actually push you in a different direction to create an over unity, but I'm not breaking the conservation of energy in the original circuit. I'm going to break it in the way I pull the energy from the circuit. So when I put the wire down the throat of it, am I breaking the actual oscillation? The answer is no. I'm not in any way breaking the oscillation. May I change the frequency by putting the wire down the throat? Depending on what I put to it, yes, I can. However, I'm still going to get frequency. I'm still going to get it to pump. Now, I want to show you something that Sean did because it's very important to understanding this, okay? Because I'm creating a pump out of the Tesla coil, as it oscillates up and down, I'm creating a pump now. I'm tapping the pump with the wire down the center. Now, as it pumps, I can pull the energy from the pump. This is the one thing that people do not understand. It has to do with high voltage lines. When you do high voltage, they always tell you it's AC. Normal sine wave, you would think it would go this way and you would have the direction of energy going one way. What's the problem? They always describe it as a pump. AC moves like this, okay? And they continue to tell you that on a power line. They're not telling you it's a sine wave in one direction. Now, because of that, you're going to get the negative to pull energy from the ground. Sounds wrong, right? That can't pull energy from the ground. It's not possible, right? Well, let's just see this. So what am I showing? The actual prong on the left is the ground. The Tesla coil is on the right. As the Tesla coil is the pump, you can clearly see in the picture right now that the energy is pulling towards the Tesla coil right there. It's pulling it in, it's pumping it. You are now getting energy from the ground. This is one way that you follow the law of thermodynamics, but you now have extra energy because of the way you tapped the secondary system. So, we'll play it one more time just so you guys understand. So when you deal with something like this, right, and you deal with the high voltage lines, are you putting energy to something, or are you just creating a pumping action because they describe it as energy like this in a sine wave instead of a sine wave in one direction? Okay? They tell you it's a pump. They tell you it's moving like a pump. So when you pump the earth, you get extra energy out. Tesla did this also when he went to the Colorado area and did the Colorado experiments. When you create a testicle and you put a rod down it and you tap it to the water down in the earth, what happens? You're now pulling energy from the earth. Anywhere that water goes is a ground. Every single part of it. Anything it touches, anywhere it flows, if it goes down into the core of the earth, anything, that's what you're tapping. That's the understanding of Tesla. He didn't want to create energy with light bulbs outside or energy with the hot side of energy. He wanted to use the cold side of energy and put a light bulb in the ground 4 miles away. Now you'll understand cold energy is a factor in your system. If you can create the correct geometry in order to amplify that energy. All right, guys, I gave my little spiel. Have at it.
Happy Saturday, everybody. Dope here.
Morning.
Tesla kind of knew, from the get-go, and he always said, if you want to understand all the things that, make our universe work, to look at the world around you, and the phenomena that you just described is not so easily observable, but yet observable in our, own daily lives. Anytime you think of a thunderstorm, and you think about a discharge from a cloud, its potential is there and it's ready to discharge. But in order for it to discharge, that charge in the cloud has to actually find a path of least resistance, as we know. And we generally attribute this to some type of higher conductor that it might be attracted to. But when lightning actually strikes the ground, that exact phenomena is observed. It's pulling feelers out of the ground by virtue of its own, potential and force, brings a charge up from the ground and then picks one to ultimately hit. But why doesn't that lightning bolt just simply hit the ground? Why does it also creep out? Well, the answer is exactly the same. The same as it was pulling energy from the ground, it was also pulling it from all the potentials in the entire area. So as it was going to find the ground, which is the highest volume of potential energy in the any given area, it also has lesser outward extensions as well, that it'll reach out and show some love on its way down to Earth. It's a phenomena that is observable, that you can actually see the feelers pulling out of the ground before the lightning bolt ever hits. How did they know that the lightning bolt was ready to hit? It's because of the relationship and the charges and the fact that they want to make that connection. It's no different than striking an arc on a TIG welder when you're holding it up to a piece of metal. Why does that arc go from the TIG electrode to the piece of metal that you're going to weld, and what's the ultimate result there? It's fascinating stuff. It's nothing new. It's as old as lightning, I'd have to say. Harnessing it being the different part.
From a man born when lightning was striking in a storm, you got Tesla. How would he not understand it from that? I mean, you know what I mean?
I think Tesla was a genius. Definitely lightning had something to do with it. I think he studied the pyramids and he understood that, like the Pyramid of Giza, for instance, it was a ram pump. And as it was doing its thing with the ram, it was putting pressure on a piezoelectric crystal, sending, thousands, if not millions of volts through the chambers and breaking the water molecules. And all that interaction, Tesla understood that. And he used that in Wardenclyffe. In fact, if you look at his patents, and his patent for a transmitter and a receiver, he's doing is completing the circuit. He has a resonant antenna that comes up on one side. It's grounded. It goes through water, goes through the minerals of the earth to the other antenna. And because there's a signal going through the top, he's literally completing the circuit. So he understood how it worked.
Bedini said the same thing. The two grounds connect, completing the circuit for the ground.
Yep. And you're right about lightning. Like totally. There's actually somewhere on YouTube, it's a time lapse capture of lightning, and it sends down like an ion beam, it almost seems. And as it comes down, lightning tendrils, they reach up to meet it, and as soon as that ion beam hits, lightning strikes from the top. They both meet, and boom, you have a full lightning strike, right? So
That's exactly it.
It's crazy amazing how if you mimic that, like Tesla did, like the pyramids did, you're gonna get some awesome extras.
So why do you see lightning as light? And the answer to that is because the potential is in interaction with atmospheric matter at that point, creating plasma. And plasma has a light discharge. A lightning bolt is representative of all types of energy, vibrational energy, electrical current, through its completion of the circuit, as well as luminous energy, and by virtue of it breaking through the atmosphere, obviously we get thunder, and I do believe that at the types of charges that a lightning bolt is putting out, you probably are creating a vacuum that it's probably traveling through at that point too, which is why it's a it's a supersonic reaction. It's actually cracking the atmosphere, creating a matter vacuum of high density energy with almost immediate dissipation due to the grounding effect.
I kind of wonder if that thunder is actually the sound transferring the energy that it takes to make the connection for light to appear.
I make it more analogous to a pseudo cavitation effect, where there's no cavitation bubble per se, but it's just an elongated cavitation bubble in the atmosphere.
I see what you mean by that.
Yeah, where there's an immediate atmospheric collapse on the grounding once the volume of matter in our atmosphere, overwhelms the electrical discharge that's then grounded.
Yeah, kind of like frying a wire with too much current between a short, right? It just evaporates.
Yeah.
Things a lightning bolt sort of. I never thought of it that way.
Sounds like a conversation from 10 minutes ago.
Right?
I just want to throw out there that, by the way, in your pyramid, you do not need to throw any kind of acid or anything down the holes. Okay. The water itself is going to break into hydrogen. Okay. Hydrogen and oxygen will flow out both the holes. Okay. So you do not need to put an additive in there. I know that that's why they see this thing as energy, but no, it's breaking the water in itself.
And think about that implosion or explosion, whatever you want to consider it. When that molecule breaks, just the energy from the break, never mind lighting hydrogen on fire or oxygen, not that it would until it gets to a certain point, but just the energy from that break is enough to push the rest of it into like a cascading effect.
To go back to what you said a second ago, Nathan, about the pyramids, and you wouldn't need an acid. Well, mind you, the pyramids were granite. Granite is mostly feldspar and quartz. Feldspar is a potassium derivative mineral, and anytime you have water, electricity, and potassium, you're going to be creating potassium hydroxide, and potassium hydroxide is an alkali. So it wouldn't be acidic, it would be an alkali reaction. I mean, what difference that really ultimately makes? I mean, just throwing that little tidbit in there.
Well,
Sorry.
it could explain the deterioration of the granite on the inside when you have it. And then the explosion, if you don't vent it properly, it's going to break the King's chamber, and the resonance that was going on in the top levels where you see each one stacked, it'll break those in half when you do not correctly vent this thing, or it has too much of a buildup inside and cannot escape. And when they actually put in those the other parts where they had the pillars that came down like this, where they controlled the actual amount of resonance in the chamber,
Yep.
if you put all of them down and have it running, you're going to explode something.
Well, we were talking about potassium hydroxide the other day in the chat. It's radioactive. So let that be another tidbit.
So the black sarcophagus that were sitting at the bottom that were full of apparently hydroxide, or at least found traces of it, could they be some sort of an energy storage? Like the pyramid itself would be like an energy pump, and it would act as like a capacitive link, and many things would come from that. But I wonder if those black sarcophaguses that they found all those chemicals in, are they some form of a battery? Like a backup storage?
Could be. I mean, and that would make perfect sense, considering that if you think about it, before 10 years ago, really, we used alkaline batteries.
Yeah.
Instead,
Yeah, you're not wrong.
Well, we only usually look at the one pyramid. We don't take into account the other two. The other two could have stored energy. I don't know exactly the configuration of them.
Yeah, that's a good point. I think they're all built exactly the same, but I'm not sure on that.
I don't think that they are.
Yeah, you might be right. I know the red pyramid, they called it. It didn't have a king's chamber in the same way, I believe. Yeah, you could be right on that. I'm going to research that. That's an interesting point. I've only ever thought of the Pyramid of Giza because it was the centerpiece, right? I know many other pyramids, but
I mean, knowing the composition of the particular granites and so on that they made up could have a lot to do with the effects that they ultimately had. Any granitic type mineral structure in itself, by virtue of what it is basically included with could be anything. So and the type of inclusions that it has is not necessarily an elemental inclusion. A lot of times it's the ionization of an element. At those types of pressures and those types of heat, you deal with a lot of radioactive ionization of of specific elements that then become diffuse into the mineral composition of the quartz and feldspar.
Yeah.
So that's how you end up with derivative minerals in there, or just literally ion, like hematite, for instance, is a good example of this because it's so simple. Sometimes hematite just straight up has iron in it, like iron composition in it. Other times it's just ionized with iron ions.
Interesting.
Into the material, forced into the crystal structure of the mineral itself, and that in itself could have very specific attributes to it, and depending on what that mineral is.
The pyramid was encased in they called it the encasing stone, but it was like a ceramic casing, so that it acted like a capacitor. And yet it would apparently glow because people would see this thing for miles and miles and it was operating, but just throwing it out there.
So let me just ask you this then. We have tunnels that go under everywhere in Egypt, right? And there's water in there, but they only put up those, what do they call those little pillar looking things? Okay.
Obelisk.
Obelisk. They put up the obelisk every so often. So if we take into the fact that they're granite, would they then pull up the energy from the water and then expand it in the air so that you could use it at
Yeah.
each one of those points where the rest of it would be in the ground?
And think about this: those obelisks at the top of each obelisk came to a point. So if evos or ball energy was collected, it would sit on top of that point, almost like a light.
Now that
Right.
would make a lot of sense, because if you're dealing with ionization, you could be dealing with literally something glowing, and also being diffuse transport, only to then have a lightning effect meeting ground at another point, depending on what is throwing up its feeler. So if you have a negative charge coming off the top of an obelisk, and it could ultimately find ground.
Okay.
Yeah.
So I got a question for you guys. The law of thermodynamics. Okay. Basically, compressed chamber. Okay. Just like under the Pyramid of Egypt. We're not changing any of the temperature of the water. Okay. Though I would imagine under the earth there is a temperature change. Okay. But I just want to address this about this. I guess, are you going to create something more than what you thought it was? So they always describe it with this little guy. He sits there with a cup of water, and then he goes like this, right? And they tell you it's the law of thermodynamics, right? The
Yep.
water moves up, it goes down, you create heat, it moves, okay? You can create pressure with steam, okay? So what happens when you create that pressure? Well, the pressure differential in there creates a hammering effect, but you don't necessarily need heat. Water hammer works on creating an air bubble in the system in order to slam the water one way, okay?
Yep.
So that's all it's going to take in the bottom, okay? And what is it going to do? It's going to create the water hammer. So when it does that, what are you getting? You're getting a wave of energy that goes out, okay? That energy hits that top point, and then the energy from that point goes like this in a wave, okay? So I think what they do not put into there in that law of thermodynamics is the fact that you get the wave. Now, let's switch just a little bit. We're going to go to the earthquake machine. This is a beautiful mind of Tesla, okay?
Mm-hmm.
I'm going to put in steam. I'm going to put in water, right? I am going to create the perfect effect in order to get that wave of energy, okay? In one side and the other, through both systems, I'm going to get that wave of energy. What else am I going to do? I'm going to make the top oscillate at a very small hertz frequency, okay? Not a very large hertz frequency, not a kilohertz frequency, very low single to double digit hertz frequency. Now, the earth itself works on low hertz frequency, okay? And it goes up, hits this thing, creates this burst of energy, right? Then it goes into your actual frequency right here. It goes into your spark gap. All of it becomes airborne. And now you have this frequency that's going out in basically a speaker form so that it travels with sound. So what happens? Now you start to resonate the actual material around you that matches the same frequency. This is another thing that physics doesn't take into account because they don't understand frequency well enough, okay? Induced frequency at one level of hertz is direct frequency, okay? It is the direct resonance, not a sympathetic resonance, a direct resonance, okay? Directly affects that material at its resonant frequency. Now, when I say indirect resonance, what do I mean? If I took 50 hertz and I hit something at 200 hertz, radio frequency tells me I'm going to get it to oscillate still, but it's not the correct resonance frequency. The correct one is 50 hertz, okay? I'm getting it at 200 hertz because it multiplies out by 2 until it gets to 200. Now I have a sympathetic resonance frequency that's not as strong. It's that simple. Tesla's an absolute genius. He actually understood it. He understood the earth. Now, How would I know this? Okay. Stick a rod in the ground, took my Tesla coil, resonated at 300 hertz, right? Well, when you reduce it based on the rod in there, you get single to double digit hertz. When your house starts shaking, you should start to realize it's time to stop. Okay.
Yep.
That you got the wrong Tesla coil in there because you're in the single to double digit hertz and you're playing with the wrong thing that you shouldn't be doing. Okay. So, just so we all understand here, the guy knew what he was doing. And some of these laws that they come out with are not exactly finished. And because they don't know the answer, they know the answer to the hot side of energy. They don't take into account the old. I looked today. I couldn't find any math whatsoever on the cold side of energy. Negative energy, still nothing. When are they going to finally figure out that there's a second side here? Maybe they don't understand Tesla's third energy, which is the cold energy. Okay? That's what he was planning to use next. I think it's time for us to fill in the gaps.
You know, that just opened up like a weird train of thought for me that directly had to do with Tesla's resonance experiments. You know, and then one thing led to another very rapidly.
Yeah, me too.
You know, when Tesla was experimenting with resonance in New York, you know, basically got kicked out of the city for, you know, more or less creating an earthquake. So the story goes, you know, but he wasn't even aware of it because his building that he was in particularly was in resonant frequency with what he was doing. Now, I thought to myself, like, well, why is that? Why could only be felt some places and not others? And why was it creating such issue here, there, and everywhere? And then that led me down to New York City and how it was built and the reason that you could have such tall buildings in New York and not necessarily just anywhere. It all has to do with the bedrock. See, the bedrock on the island of Manhattan is pretty shallow, very thick, and is solid quartz, solid granite, solid granite. Okay. If you have one of these high-rise buildings that's bolted directly into the bedrock, which is how they build it in New York, it's why they could go so high. All right. Now you have a sympathetic, it would be sympathetic frequency attached to the Earth's frequency in that building, that if you then hit, you'd have perfect stillness at that point in your, as far as you're concerned. But everything else that isn't bolted down to that bedrock would shake like nobody's business.
That's
I
crazy.
think I know what experiment he was shooting for when he made that building shake. He was looking for sympathetic resonance to make it disappear.
That'd be cool.
Think about that. If he could make that thing resonate at the right frequency, it wouldn't shake and rock. It would just.
And that's what I was saying. That's why I said it would be absolute still. It would be as if nothing at all was happening.
Also,
because he's in the building's on the granite. He's shaking the building now in perfect resonance with the earth of the granite that it's tapped to. See, there's a harmony that's balanced when you bolt into the structure of the earth. You know, like it and if it's not the right materials and it's not the right stuff, and there's little things that could happen that could lead to really catastrophic failure, you know. But
wow, so his earthquake machine, in a sense, when it was creating earthquakes, was a failure because he wasn't trying to create earthquakes. He was trying to create a resonant bubble of time. Wow, that's
So hold on. It would be invisible to us because we only perceive certain frequencies. Like we can only hear certain frequencies. Our eyes can only pick up certain light spectrums. Okay. So would it just be blind to us, but still be there completely?
I disagree. Okay, so I sort of disagree a little bit with the whole making it disappear thing. And and I want to be corrected, please, if you think differently, and I know you
I'll
would
tell
anyway.
you why
But-
after your
Well,
go ahead.
So the thing is that I think that in order for that type of time space dilation to occur in that location, I think that it would have to be closer to Planck's distance than the native resident frequency of the underlying granite. So I don't think disappearing necessarily would be the effect. I do think that by capturing the point, especially on a pendulum, of absolute still, okay, then you could map exactly what the resonant frequency of the particular building is. Now, since the building he's in is hit to granite, you're then dealing with Schumann's resonance, right?
Yeah.
That's
So,
really
right.
what you're dealing with, right? So you're dealing with Schumann's resonance. Now, I'm sure he would have, contemplated that aspect of it, but to see if there's any deviation or variation between the building itself and Schumann's resonance to conduct that experiment, he would have to, vary the resonance of the building to see what the still point was to know the offset of the differential. Does that make, I don't know if I explained that well. That's
completely because
I think he was just trying to find the resonant frequency of his ambient environment.
well, yeah, but that goes to the same experiment. I'll tell you why. I was doing an experiment with my quill, and I've talked about this on previous lives. I've documented it. In fact, the 5 people that I talk about with affidavits signed affidavits to this very experiment. It was something didn't expect, but it happened. I was resonating the coil with my house. And what I was doing was I had the coil going at a certain frequency. I had the back EMF go through a step down transformer, which was a microwave transformer, went from the high end to the low end. And in between the high end and low end was a spark gap. Then from the low end, it grounded out to the water pipes in my house. The house I had was a 4,400 square foot, 4-story mansion. I was renting it. I didn't own it. Okay. So anyway, because it was grounded throughout the whole house and I was resonating above the ground, it was pumping. And it was pumping that time energy into the bubble around the coil and where I was. Now, we had that thing on for a certain amount of time. My daughter, who is like 7, no, maybe she's a little older at the time. I can't remember. I'd have to look at the notes. Too much on my brain. I apologize. But she came to the door and knocked on the door, apparently, and we weren't there. Because when I shut the experiment off and opened the door, there she was crying. And she was like almost frantic. Where were you? Where were you? We were right here the whole time. No, you weren't. I went into the office. Nobody was there. So were we resonating at a different time, at a different frequency? Because we oscillated? Now, think about this. When you're using 2 frequencies, okay, and you want to have a third outcome, a third component, which some would consider, it was in the Whitaker papers. So Thomas Bearden talks about it.
I know the one.
So if you were to pulse, say 10,000 hertz one way, let's say you wanted to resonate at 1,000 hertz, and the Earth is at 7.83, but you need to cancel out that 7.83 and still resonate at 1,000 hertz. So you would pulse at 1,007.83 hertz, and the Earth would pulse it at 7.83 hertz. And as it oscillated back and forth, you'd create a bubble. And that bubble in between that oscillation is where that time differential space is. That's where we were standing. That's what Nikola Tesla was trying to accomplish with his earthquake machine. But he was thinking mechanically with gases and movement, being able to resonate it, not considering, or maybe he did consider, I don't know. I wasn't in his mind, but I look at that experiment and go, what was his purpose? Because he's not like, you know what I mean? He wasn't trying to get an earthquake. Why was he trying to vibrate the whole building in resonance with the earth?
All right, so I'm gonna wreck your mind with this now.
Okay.
So think about cavernous material, or cavernous material effect.
Mhm.
And take it out of the context in which it's usually kind of thought of, and put it into context with this, with Earth's resonance. And then you look at the fact that these cavities are taking the resonance, amplifying and condensing and consolidating it, getting it trapped in these pockets. And then consider that that it would then have an overall resonance effect on the shell, so to speak, above it, and whatever's on top of it, and what type of time and gravitational effect that would ultimately have by the offset differential.
Yeah, because there would be one. Because think of it like capacitor plates, right? The speed in between them is different than the speed outside of them. And if you can resonate and create that bubble in between it, hold it, and if you're inside that bubble, you're in a different space than the space around that bubble or between those two plates, right? So it's the same effect. It's just, I think physicists haven't been able to understand that, or if they do understand it, they haven't been able to do it. There's a mechanism behind it, right?
The more it gets spoken about, the more it just like always boils down to exactly that offset differential offset. And then that just leads, because it's offset and differential, what does it lead to? It just leads to a matrix of zeros and ones. Doesn't it make you feel like we're in a simulation?
I don't know. I'm not, I don't aspire to the simulation theory. I get it. I do. But I
don't know
think
that I mean that in a literal sense, more a matrix. Pardon me, a matrix.
Okay, I understand
Fair.
that. Yeah, that's fair. That's fair. I forgot my point before that. Oh yeah, you were saying the more it gets talked about, more it gets out there, more people will start to look at it, right? Well, there's already science groups that are looking at our work going, we need to get free energy. We need to find it. We're at the tip of the spear, man. We're right here. I don't care if you're doing the work. And if you have to do it scientifically and you have to have $100,000 worth of equipment to prove your point, go right ahead. All the power to you. I love it. The fact that everybody's working on it's great. If there's a little bit of strife between scientific groups and we all push each other to make it happen quicker, right. You know what I mean? So we're at the tip of the spear. Next week, it may be the other group. We'll see. Let's
as long as your name's not Jack and calling me a schmuck.
But
Listen,
Jack
I've had
is a
my choice
schmuck.
words.
That's what Jack is. He even admitted he was a schmuck. He says,
Oh,
"We're all schmucks."
He's a credentials shown schmuck.
Yeah, he's got credentials of being a schmuck
Sorry.
and
like
a reputation for being a schmuck. And his hair looks like a schmuck. I mean, look at mine. I got some schmuck hair here too.
I use much more high class technical language to describe the gentleman in the chat.
Yeah. For me too, it starts with an A and it ends with an E.
Yeah. I think I called him a shriveled up geriatric bee bag.
You know what? I'm not gonna bullshit anyone. I like Jack. I love how he's such a dick. You know what I mean? Because when I grew up, my uncles were all like that. So to me, it's just like going home. It doesn't bother me. Anything he says, it's just like, but you're right. If you were to look at him as a physicist and talk to him and try and get your point across, yeah, he's a dick.
You know what? You know what the thing is, I think for me anyway, is I could always respect any good information anybody wants to give. And nothing they're going to say is going to bother me at all. Like, I don't take anything personally, and that is what it is. But what I don't like is people like this. Nah. See, that's a personal thing to mine, where it's like, you can't even have a discussion with them, because if it isn't what was running through their head and it wasn't what was coming out of their mouth and it's not singing their song, then it's worthless, it's garbage, it's nothing. And unfortunately, like, I tend to lack respect for those types of people, which means that
That's why
I
we're
wouldn't
here.
even bother with them. Like,
That's why this
thanks.
group was put together. Concentrate on the science, get it out there, prove positive. Let's not worry about the negative or the drama that sits in the background, even though there's a whole bunch, if you know what I'm saying. Let's just make this happen real fast. And if next week they're at the tip of the spear, which I kind of feel unlikely about, but
hey, listen, if they're at the tip of the
great,
spear, it was only
just
because of what everybody here was doing. So, like, it is what it is. I'm not trying to take credit where credit's due
No,
away
me
from
neither.
someone, but it happened.
No.
I think it's inherently true. You don't go
Yeah,
from point A
I'm
to
not-
point B instantaneously.
Yeah, please don't misunderstand. I'm not saying we got a touchdown. That's not what I mean. Okay, that's not what I mean at all. I just love the fact that there's push and pull between groups, and we're getting it done. Now, if you're gonna take credit for what we're doing, I think you're a bunch of pathetic beings. Just like if we took credit for what you guys were doing, we'd be pathetic, right? It's just not. It shouldn't be done. Science is about integrity and about doing the experiments. And when we find what we find and we put out all the material for people to repeat it, then they can debunk us and spit at us and all that crap. Till
Hey,
then,
I just learned something new. Nathan, did you know they had football in Canada? I didn't know that.
Yeah, CFL.
yeah, we do with icicles from our beards and
As a matter of fact, it's actual football.
writing that
It's
one
not like
down.
down south where they call
Football
it
in
football, but
Canada.
it's soccer.
yeah. Well, we actually do play football. You're right, Nathan. It's not soccer and we call it football, right? We're not
Yeah.
the English.
Yeah.
Okay, so let's get back on track here. Okay, we're going to talk about empathy, or excuse me, entropy. I can't even say it right now.
Entropy.
Okay.
I gotcha.
Entropy. Oh, entropy. I love
Thermodynamics.
Absolutely, Gerald, take us away.
Entropy's the best. You want to know what you do with entropy? You let it happen and you capture the flow as it's starting to drain down the tube. And you take that flow and you put it in another spot, and then that spot builds up, and you take that build up, you slap it into the first flow, and the other flow goes back, and it just keeps wrapping around itself like a nice donut.
Watch this. But Gerald, you can't do that, because once it's depleted, it gets dispersed and diffused too much, and then you can't recapture it and put it back in. So what now? What do we do? I don't know.
Just the very flow of energy pulls other energy in. And if you use a bunch of instabilities that electrical engineers try and do their best to get rid of, like Dicotron instability, the skin effect, there's multiple. I use 7 in my system all together. All those little things coming together equate to constructive interference. And by using that, you're able to manipulate the flow of entropy by capturing it. If you didn't have those things, it wouldn't work.
But Gerald, you can't do that, because entropy works like a box of dice that you shake around, and then the pieces are just all over the place. And chances are it's on one side of the box and not the other, and it can never be like whole again. So what are you talking about, Gerald? Because you don't know what you're talking about.
You're absolutely right. But through geometrical forms and making the path of least resistance for energy to flow, you're able to take those pieces and they literally pull themselves together into the place where you need them to be, so that when that energy is flowing and it gets all angry and tries to shoot backwards, you capture that backwards flow. It's all part of the entropy itself. And that allows you to control temperature throughout the whole system. Taking the cold, putting it where you want, taking the heat, throwing it into the circuit, throwing it back into another pole that sits around your whole system, and allowing it to teeter-totter through temperature.
But Gerald, I had a 5.0 and I read all the textbooks front to back, and my professor told me that this could never ever be the case, and knows everything very clearly. He's an avid Marxist, and he wants the world to be a better place.
Well, I've done about 8,000 experiments. I have 14 binders on notes. I've got 179 separate geometrical electromagnetic coils, and I can back up everything I say through experiment. I have 217 videos that literally talk about everything I've done and prove through different series of experiments that I have what I'm saying and that physics is not broken. They're just not looking in the right direction.
Well, Gerald, I think you're an idiot. I'm going to call my professor and tell him all about the nonsense that you're spewing all over the internet with your disinformation and all of your whack job crackpot theories.
Well,
okay.
Thank you very much. You can tell
You're
your
welcome.
professor that I have an ID10T problem and his wetware interface is broken.
All right, guys. So, well,
Sorry,
let's look back in high school.
Listen,
I had
someone had
to
to do it because you're not going to get someone on here to actually sit there and play devil's advocate in any sort of meaningful way.
that was great. I love that. That was lots of fun, actually.
Okay,
It really
so
was.
real quick, the way I see it, you got the heat on the outside, you get the cold on the inside.
Mhm.
You created flow in the direction of your coil. Okay, so now you get a magnetic field. Okay, a
Yes.
field, not atoms, but a field.
A
When you get your
compressed
field, that's right. So that I was getting to that. Okay, inside the field, because it's a coil, you're going to get a massive compression in the center. Okay, in that compression in the center, your Tesla level is going to be higher than it is on the outside.
Yep.
That's pretty much common. Now, here's the beauty of the circuit. Okay, as it creates a field. Okay, now you take that energy, and like Gerald says, the energy flow goes in there. Okay, and it goes back around it. Now, the compression of it is where it gets you because it gets colder. The more you compress it, the colder it gets. The colder it gets, the faster you get to a superconductor. Okay, that's the easy version of how it's working. Now, here's the hard part. Now, if I sit there with that superconductor, just the way I described it, right?
Mhm.
I have to put another layer on it. I'm going to put resonance frequency on it, okay? But I don't just have one, okay? I got several in this thing because I did different actual configurations of how I build the coil, right?
Yep.
So on each layer, you're going to get a different one depending on which one you get. Some of them will be in sympathetic resonance. Some of them will be in direct resonance with each other, okay?
Hold on 1 second. Pause, Nathan. Mushroom fractals. Continue.
So I know exactly what you said. Okay,
I'm listening. I'm right here. I got to grab something.
God got me off track. Okay,
I'm really sorry.
it's all right. So now, once you have your resonances in there, you also have to understand that between each wire, okay, what you're going to get is a bowing factor. It goes like this, okay?
Mhm.
And each one of those, you're going to start to get out of your frequency, your actual music scale, okay? You're going to build your fifths. You're going to build your thirds. You're going to build all of this in there, right? That's another layer to your coil. Now, you start to have all of these things in there. Again, you have your field. Don't ever forget the field because then you'll screw everything up, okay? That's one of the main things you have to start with, okay?
Yep.
Now, what that's going to do when you create the field that goes this way and you start creating the directionality, now you're going to start to create the vortex. Now, it doesn't just go on the top, the vortex goes on the bottom, okay? Here's the critical thing. You're pulsing it, okay? So now you don't just have this stack. You have this. You have a pulsed stack. So why do I always equate that to a Tesla coil? Because like a Tesla coil, I'm creating my pump. Now I have a pumping action inside of my coil. Now I have my vortexes pumping. You now can add, okay, the Russell scale directly to the center, up to the top of the cone, and you now have a very beautiful system, okay? But it doesn't stop there.
Oh, wait, there's more.
Because you're actually pumping fields, okay? One and the other, you're going to get sound.
Yes.
It's a giant speaker, okay? It's an absolute beautiful thing, isn't it? It's a full system. It's not partial. This isn't halfway thought about. It's a beautiful system that has everything. Go ahead, Joe.
Oh no,
Sorry,
that's dead on, man. Like it's got it all. It's got it all because it is it all. And yeah, man, it's I had so many things going through my head, but I mean, I understand that system. You know, what the pumping, it like I always go whenever I think about these things, I go to the ocean because the ocean has so many answers. You know, as to how you could observe these things in action in nature. And if you think about a jellyfish and how a jellyfish moves with that pumping motion in its field, that is exactly the same type of force that needs to be created against each other in order to have that type of, you know, effect. If you had two jellyfish swimming away from each other, but maybe having their tentacles tied together.
Yeah,
You know?
by the way, he said no math. We're
No
not
math.
talking about math here. We're simply moving fields and energy around. Okay. But this is okay, just so we all know, this is why we create two different systems here. One system to run it. It never loops back to the system again. Okay. It simply runs it. It's a starter motor. Okay. It runs it. That's all its job is. We never rotate it back to it. Okay. That allows this coil to turn on. Once the coils turn on, all the special features of the coil take over. Now we have our system, right? So now, once we have our system and we tap the system, okay, it's just like Victor said, the cup never goes empty, okay?
Nope.
We never mess with the starter motor because we never get an empty cup. That's the full understanding here. We'll always be able to tap the energy from the center because that's always full, okay? It's the exact point you need to be at in the system. If you try to take your original system and you try to loop it back, okay, you lose the energy in the actual coil and you destroy it, okay? You have destroyed any chance of getting anything. You have to tap the center, pull it to the side, put it in some storage, okay, device or however you want to do it. Then you can take from that storage and loop the system that way while you're still pulling extra energy out. But you are required to have a storage device.
Yes, absolutely. Whether it be capacitor or a battery. Okay, so like you said, when you start pumping your coil, I got the coil a little bit wrong. So as you're pumping your coil, you're pulling in energy from your atmosphere and from your environment, as well as the flow of your energy going this way and this way, and eventually meeting. Now, I know it's offset, but you could do it like this. Because it flows like this and it flows like this, you're pulling in helicity from the top, basically a cold vortex. And what's magnetics? It's hot, it's heat, right? And you're pulling that from the bottom, and in the center where it meets, you're creating what I call a null zone, what Joe calls the perfect zero, and what everybody else would call the plane of transmutation. And that's right in the center here where everything meets. Right? The cold meets the heat, the electromagnetics meet where the electricity meets, the static meets the, you know what I'm saying? The positive and negative meet. My brain just turned to cheese there and it farted, fell right out of my ear. So anyway, that's where the compression meets, is right in the center of this coil, where both of the fields, while they're spinning in opposite directions, that compression happens right at the center of the coil. And then there's a null zone right there. And that's where it pulls in the vortex from the top. And when you have a ground, it pulls it in from the ground in the center. But the circuit itself also has a separate ground. And if you're using a battery, you have to have a second battery. Why? Well, this is the fun part. So your coil represents your center line kind of thing, right? And your battery over here and a battery over here.
Joe, watch him. He's drawing circuits again.
Here we go. Wait, see how you even screwed it up?
I like them a little smaller than you did last time.
You know what?
They age better. Everything gets smaller with time, right?
You're not wrong.
Oh.
So what do these two batteries do? They complete the circuit.
Mhm.
Mhm.
So your two batteries act as two grounds. And because they act as two grounds, when you're oscillating, it acts as a circuit within your room. So if you were to have two batteries within your coil or using with your coil, and you had a battery on one side of your room and a battery on the other side of the room, you have a potential for time displacement by the very oscillation that's going on between ground and coil. Know what I mean?
Listen, that's for those of you who've been following these Saturdays, that is the creation of separate locality. Is that, double battery, double ground.
And
That's
the
right.
cup, when the cup gets full, I don't know if you can hear this, it rings.
Yeah,
Like a
That
bell.
sound keeps the energy flowing. Yeah.
that's right.
So that's where I'm at. Just wanted to kind of elaborate on what you were saying.
It's
What?
a strange thing in the sense that it's closed system
Mm-hmm.
that also is a breathing system within its environment as well. It is both in unto itself and of use of the environment. And that's the duality that's created by the separation of the locality. So
And the temperature transference. I think that's what you referred to it as, Nathan. Temperature transference. You can take the heat and put it in your circuit and take your load right from your circuit so that the system stays running in its loop and that cold stays in the center of the system, which is what you want. You don't want it to get hotter. My coils don't get hot. Not unless I'm using too much power, and then of course, like everything, it gets hot. But I don't use too much power in the sense where how do I explain that? In the oscillation, my primary starts to heat up if I'm not pulling enough of a load. The load defines the system. Unless I'm slamming, it's like I'm forcing everything I can through there, then it'll get hot if I'm not pulling a load on the back end. And there's actually a reason to do that. But that's
well, if I may, it could be difficult also to take those specific measurements, temperature measurements, because they're not necessarily they're impacting the matter in the environment around it, which is what would become measurable. But the points themselves of the lowest and highest temperatures would not necessarily be measurable because there would be nothing, no matter to reflect off of, to pick up off of. And if you were to insert a non-light, like a non-laser form of measurement, then you're introducing actual matter into it, and that would actually create deviation in it. What I mean by that is, like, when you see the cold point, getting warmer, right? it's not that it's getting warmer, it's just that the point is becoming more consolidated, more compressed into a point of space,
Oh yeah, okay.
you know,
So-
without matter actually to affect and measure the actual temperature. So the ambient temperature of the matter surrounding it might be warming up, but the actual point itself, in my opinion, in that it would be pulling harder to a smaller point, but the smaller point being just as cold.
I've shown on my infrared camera that my coil, the ambient temperature is like in the room's 23 and the coil's 19. And in the center, the open core, it's darker than that. But I can't get a reading on it because the little digital, like the meter for the infrared, it just bounces around and it won't capture that spot.
Won't capture the spot. Exactly. Because it's not in matter and it's not sending it back, you know, properly.
I never thought of that.
Yeah, it's not sending it back. And it, frankly, it could even be dissipating the infrared sensor portion of it and eliminate. Yeah, so you can't even measure the temperature of it.
I can
No,
measure.
you can only measure the ambient temperature of it.
Well, yeah. Well, the temperature of the coil, which is usually lower than the ambient temperature of the room, but I can't measure the temperature of that open core when I have the cold centered there. And that's when I'm pulling a load from some other spot other than the center.
No, I don't want to deviate off point all too much, but it's not. It's what we were talking about just before the cast, because it's funny how the universal minds all, like, Gerald came to the plate with one thing that he was like wanting to discuss, and Nathan came to a point that he wanted to discuss, but then like totally separate of the two of them, I came with 2 points that I wanted to discuss, which directly overlap both the things that they wanted to discuss. So I was like, "Oh, go figure." You know, but one thing that I was contemplating was just how the idea of the ambient temperature of open space, okay, is like 5 degrees Fahrenheit or 10 degrees Fahrenheit, something like that, on the north side of absolute zero.
Yep.
Okay. And what that indicates to me is that a couple things. First of all, you really can't measure absolute zero. Okay. You can't measure absolute zero because there's nothing to be at that temperature to measure.
Right.
Okay. So you have no reading. You have no way to read. That's first off. Second off is the fact that the ambient measurable temperature is only a couple degrees above it just shows that the mass to or matter, I should say, matter to energy ratios in those particular areas
Yeah.
are far out of, you know, equilibrium, far out of equilibrium. So if you have a piece of matter that is of high energy depletion, almost no hydrogen bonds, okay, and then it's in an area of emptiness, so to speak, it's going to be able to achieve the lowest potential matter temperatures that are measurable. That's where I'm going with that.
I did a test with a smoke detector. I pulled apart the part that holds the Americium 241, and there's so little in there, right? A Geiger counter will pick it up. And I have a Geiger counter. It's a very cheap one, though. So it was a weak signal. And this is no conclusive test whatsoever. But once it gets properly out there and we can test this properly, I put the Americium 241 in the center of the coil and I pulsed it and put the Geiger counter up. Nothing. No signal whatsoever. But before I put it in the coil, I was getting a weak signal. So I don't know.
Temperature, time, or both?
See, at that point, I wasn't controlling the temperature the way I can now. So maybe that had something to do with it. I don't know. Like I said, it's a very inconclusive test. But maybe it goes to what you were saying, right?
Yeah, well, where that was all tying in with this, with the absolute zero or close to it, is the superconductivity properties.
Yeah.
Okay. And then now tie that into the temperature, the low temperature differentials at the center of the coil where it's exhibiting low, superconductive properties.
Yeah, I guess that would be superconductor. Like I look at it as a room temperature superconductor, but it's not confirmed and it needs extensive testing before that can be declared outright. But I believe it is.
I mean,
Right?
even if it has anomalous superconductive, attributes where, it's for a small fraction of a second or whatever, it goes back to the rock. But things
Yeah.
don't do this.
Well,
It goes back to the rock, but things don't do this, but this does. So
it repels magnetic fields. Like I hit a button and I can shoot the magnet halfway across the room.
Mhm.
And then I can have a smaller coil sitting above a magnet and repel it not once, not twice, but 3 times. So and I do it for 1 watt, 2 watts, maybe. I believe that's superconductivity. I don't think there's anybody out there doing magnetic levitation with less than 15 watts. They all have to have that little 15-watt wall plug, and they get that little electromagnetic thing, and it just sits maybe half an inch above their system. Mine's going up almost a foot.
Yeah.
Like Nathan said, it's a bubble inside a bubble, right?
Yeah.
So I believe, it's superconductivity at room temperature.
I got a question for you. I know you put like a lighter or something in the center of your coil. Have you ever cooled it down? Like put more cold air in it?
No, that's an interesting experiment. I did pulse it and put it in a container of water and then froze the container of water in it. And in the end, you can see the transverse waves in the water, like frozen in the water. And I was pulsing it while it was freezing, but I never tried cooling it down. That's interesting.
Well, I just wonder, would it actually make it faster to get to a superconductor if that's the effect that you're getting every time it cools?
Well, you know what? There's a good test in trying it. We get winters here that are pretty cold. So in another month or so, bring that experiment up again. And I'll literally, while it's running, we'll do the test inside and then I'll do the test outside. We'll wait till it's like minus 20 degrees Celsius outside, which should be in another month or so.
Well, because if you put it in space, it's going to be the same thing. I mean, you're going to have colder temperatures, but also you're going to have, how do I say it? Like a different effect on it too.
I can say this. When I was pulsing it in the water and it was freezing, the LED that I was using in the circuit to pulse did get a little brighter. But I don't know if that was because it got more conductive as it got cold, or I'm not sure. So, yeah, you know what? I'll definitely have to cool it down.
Well,
That's
like
good point.
vacuum chamber. If you had a vacuum chamber that you put it in and added the cold to it, then you would have an accurate thing of space. That's what I was thinking of earlier. Sorry.
Yeah, I'm frustrated with that. I'm working on it. One of the glass bottles that I was trying to cut broke. So I have another one, and I'm going to get this one professionally cut because it's going to be the basis of the vacuum chamber. And I already have the vacuum pump, so sorry, had to fix the kittens. So yeah, I definitely want to try it in a vacuum chamber. I kind of have to actually. The big coil is showing even more open holes today than it did yesterday, and I didn't do any pulsing. So, I don't know,
dissolving it
or evolving out of the fluid. Like,
I got a question for you. I know that when there is no epoxy there, right? No resin.
Yeah.
That you're actually probably getting the oh God, I can't even talk right now. You're getting the plasma, right?
Yeah.
You get ozone. Okay, so it's a small bit, a little bit of ozone somewhere in there.
Nope.
What are you getting?
I don't get ozone. What do you
Okay.
mean when I'm running like when I get plasma from the coil?
If you didn't put it in resin, sorry.
Oh, okay. If it wasn't in resin, do I get no, not unless I'm using like the 3000 volt 3 kilohertz pulse from the plasma globe. I don't get any ozone in there at all. But
You'd get ozone even if it's resin dip though at higher powers.
no,
Yeah, I was trying to get my head around that. Okay.
I don't create ozone for some reason unless I'm using like, I call it pumping hard. Like unless I'm using high voltages, I don't get ozone at all. But I put it in resin because I had grounded it out to my table and did a test, and 5 balls, what I thought was plasma at the time, showed up in perfect configuration at the bottom of the coil. And I thought, okay, well, this is breakout. The coil's messed up, right? And I shut it off and flipped it over, looked at it. There was no burn. I put it back on the table, ungrounded it, put caps on my secondary, and then did the test again, and the coil was fine. Like there was no breakout at all. And I was only using 24 volts. So I believe it was creating EVOs at the time when I grounded it out. So I put it in resin to do more tests. I did not think I would have the outcome that I have now. So if it was ozone, I would agree with you 100%. Ozone's blowing the resin apart. It's eating it, whatever. But I don't get ozone. And lots of people that have been around this can attest to that. There's no ozone in any coil test that I do.
No, when you showed those bubbles, they look very like cavitation bubble to me. It looked like a hard, quick strike of dematerialization.
Kind of. That's what it looks like to me, but I can't prove that, right? I'm no
No,
expert.
really.
And so
I mean, you probably could if you opened up the resin and scraped out the inside and had it tested to see if there was any sort of transmutation that took place. I'm not familiar enough with the chemical composition of or whatever polymer that would be to understand what you would expect to get out of that test. But
well, see, that's the thing. If there was some great purpose on that test, I would consider cutting the coil in half and sending a whole block to Bob Grenier and ask him to do it. You're the expert. Have a look. Right?
Okay.
But I don't want to cut it in half just yet.
So I got a question for you then.
Yeah.
If you're not getting ozone, are you getting scalar inside there?
I believe I am. I can't prove it, but I mean, I run like 400 volts of LEDs with 12 volts, 2 watts. That's not possible. I mean, they're not full, but they're like 65, 75%.
So then if you're getting scalar, are you pulling that scalar through the center of the coil?
Yes, but it doesn't just go through the center of the coil. Because it comes out on the sides, it acts like a connecting point, right? So it's like this. Oh, here we go, circuits again.
yeah, the scalar in that should propagate out longitudinally.
Yeah,
or in depending on what the configuration is. It depends if it's bringing in or putting out.
Yeah, it comes out the sides of the coil.
But I mean, Bearden seems to think that you could direct all that scalar if you wanted to. It's just a matter of having the propagation into a resonant medium, and a resonant medium that is has directional lattice flow. So if you could get it into that, and then it has a directional lattice flow, like a piece of quartz. I've said it a bunch of times, you could ultimately have a scalar propagation.
I haven't done tests with any of the quartz I just bought. I still have it. That's scheduled for me to do. It's just the thing my brother had to put some stuff off. But when it comes to scalar concentration, it's next to impossible. I've taken a pickup coil and put it beside my big coil running a pulse. Then I pulled it aside, put glass, still got voltage. Pulled further, I put aluminum, still got voltage. Pulled it further, put wood, I put steel. Didn't matter. I was still getting voltage.
Yeah, huh?
Went through all of them. And I was like, okay, so maybe it's going around these plates. So then I took an aluminum. First I took a glass bowl and I put it over the coil. Nope, still getting voltage. So I took an aluminum bowl and I put it over that, and I still got voltage. So it wasn't coming out and reaching to the ferrite core; it was going through everything.
I'm going to be the prick that's probably wrong, but says it anyway. I have a hunch that it has to do with the frequency alignment and the phase of how the wave interactions and how it travels through the wire are ultimately lining up. To get it at absolute cancellation, you'd have to have a certain. It would have to be very, very specific. It would have to be a certain length of wire. It would have to be certain turns of that wire coming from two different sources of the same input, okay, that are exactly aligned so that your frequencies are totally aligned with each other. So it's a math equation and a game of tolerances.
Okay, so you're not an engineer, but you got it. Because here's the thing. If I'm running my coil and I want to stop that signal from going out, I got to put 12 pickup coils on the outside to absorb the power and absorb that signal. Then it doesn't matter. It's all contained, right? But if those aren't there and I just put things in front of it, I'm still picking it up on the outside of the ferrite core. But if there's 12 sitting around my coil, cancels it out. It just grabs that energy and then I can put it back into the system. If that's what I wanted to do.
Yeah, no, I'm not an engineer. I just have a background in everything.
And you see things, right?
And I see things.
Yeah.
I do. It all helps. I don't know if you know that about me. I didn't really ever share too much about myself. I don't want to talk about myself. I don't like that. But I have a little bit of a history with doing electrical work. So I know how general circuitry works, Awesome. And then I was into welding and fabrication, went to school for it for a few years. So, I'm familiar with all that side of things too.
Welding's important.
And those two elements, I don't think if I do those two things, even in conjunction with everything else in my life that I've ever known, I don't think that I probably would have had the aptitude for this sort of thinking that I ultimately do. Really understanding what a welding machine does, if you get that, you're kind of halfway there.
You're right. Because of the way that metal dissolves. Well, dissolves not quite the right term, but
it kind of does.
The way that it bonds, the way that it crystallizes, the way its matrix is between two different metals, the whole nine. There's a lot to know.
So let me just say this for anybody who does physics for a living, and you needed a paper to get to a Nobel Prize instead of getting people who created an AI program. Okay.
Sorry.
What you actually need to do is to take this cold energy and start calculating it. Okay. Start taking negative energy and start calculating. There's so many examples of negative energy systems. It is an absolute travesty that you do not do that. Okay. Then this will be more understood in physics. Okay. The reason it's not because you don't have the math for it. We're building it. You don't have math for it. Okay.
Yeah.
Where's the miss? The miss is in this, not the inventor's problem. It's how you're going to describe it. Now, can you create funny math that doesn't work? No. You're actually going to have to pull out some Pythagorean theorem. You're going to have to pull out math that has to do with geometry. Okay.
Yep.
Now you're going to start to understand it. Understand that fields are separate than atoms. You're going to have to learn that, okay? Because this stuff is telling you that it's doing it, okay? That's something that I would do if I was a physicist. I would stop, look at it, negative energy. Hey, there's a whole, bundles of papers can be written about it. They're saying they're getting cold energy. Hey, let's stop right now. Let's not question if they're getting it or not. Let's mathematically try to explain if they're getting it, okay? It's a different point of view, but it's the correct one to take. If you do not have math for cold energy, be the first, okay? Show us how it works.
For those
The physicist you just asked that rhetorical question to just got back to me, and they wanted me to tell you that the tapestry of the cosmos is intertwined.
say that again.
The cosmos of the tapestry is intertwined. Oh no, sorry. Those were the guys that wrote the AI paper. My bad.
Oh, right. Okay. Now I get it.
This is a really corny dad joke, man. I do it for
Oh,
kids.
It's all good. My brain kind of went, wait a second. If they're serious, my
It
brain
says-
took a leak out of my head.
Watch out, Ken Wheeler's going to claim that he thought of it first.
There you go.
That's okay as long as he has math with it. I'm all right with it. Let him take some photographs of it too.
Well, for the mathematicians, if you want to look into this, look into like multivariate calculus or the Hilbert spaces, the Whittaker potentials, the orthogonal group. You could look at the quadratic form, the S vector field, and one of the most important things, the Lorentz transformation. So look into those things, and you'll find exactly what it is that has been done here. It all comes together.
Yeah.
Just saying.
Well, it's an important thing to point out to people because they always want to disprove a system, right? But the hard thing is when you see things on Gerald's channel, you start to realize that the system's right. You realize that the energy coming out of the center is bigger than what's actually going in. You can't deny it. Okay? Your best thing to do is explain it.
Well, you know what? I've heard the camera trick and the meter lie argument, and so I had people come over and witness it, and then they spoke on it. And it still doesn't matter. Debunkers will debunk. The only way it's actually going to be proven is when it gets into your guys' hands and you guys actually like start testing with it. And that's, what needs to happen. It needs to be looked at extensively because this, I believe, is going to help a lot of people in the future. Maybe not today, but in the future at least.
Well, there's going to come a point where we realize, hey, it might be cheaper just to put this kind of system in place. Then we can take, because we built the lines, we built the infrastructure around it. All we have to do, okay, is charge them for that, and we change the energy source. That's really not a difficult thing to do.
Speaking of which, I've been testing and I've been getting good results. I think I'm going to leave the results to my presentation.
Okay.
But when you pulse my coil and you take a coax cable and you put the center energy to the center of the coax cable and the outside pickup coil's energy to the outside of that coax cable, I get it all out on the other end. And I'm at 200 feet right now.
Nice. By the way, I love coax cables.
Well, I kind of wonder what the math is on that for superconductivity. What's the drop off in distance for energy between a 200-foot line of coax cable between point A and point B, right? So how much voltage do they lose in that distance normally? That will tell me how much or how well or not well that I'm doing in this experiment.
Okay, just let me tell you something with high voltage. When you run a high voltage through a coax cable, what makes it so perfect, okay, is you have the center wire. Now you have over top of it, you have a normal covering, right?
Yeah.
But now you have another set of wires that's in a mesh.
Yes. Yeah.
But on top of that, you have another field that's actually like a mylar type material, okay, that sits around that.
Yeah.
And then on top of that, you have an outside field, right? So in high voltage, I'm not letting it escape because we know that voltage runs outside the line, not inside the line, unless I pulse it with DC, which I'm pinching line, okay? Now, why does that stay in there? Because it's not allowed to pass. Every single thing acts as a barrier when you get to a wire, okay? So when you take your initial center wire and then it builds out to your actual ground wire, which is your mesh, okay? It holds it in there, okay? Which is 10 times better than your actual rubber that you have on a high voltage wire line, okay? So now everything stays in there better so you can go longer distances with it and not lose high voltage. I know this because I can run 200 feet of it and still get the same high voltage I put into it at the end of it, okay? Why? Because it's not leaking. But if I do it with the wire I put on a trailer, okay, to hook up my brakes, it's going to leak everywhere, okay? And I can start things, you know, glowing light bulbs all down the line, okay? There is a huge difference. That's why I love coax cable, because of that simple fact.
Well, that whole
holds
thing
it all
was, it
in.
was a band-aid for a problem that they didn't have the infrastructure to fix at the time. You know, they needed higher bandwidth, little loss, big runs, but they just didn't have the infrastructure for fiber optics and stuff like that at the time. So they just utilized the existing technology that they had, and they just had to have a better way to transfer the bandwidth, you know. And if you want to think about bandwidth, you know, it's all analogous to, you know, low loss frequency. That's all it is. Low loss frequency.
It makes me think, when we're building this ship, that's what we're going to be using to run the cables around the ship. It doesn't affect anything else. We're going to be using coax cable to transfer our energy lines.
Don't be shocked if coax cable didn't initially come off of something.
Never thought of that.
You know,
That's
like, not for anything, the coax cable doesn't work with it without that aluminum mylar that they put on there.
You're not wrong.
And guess what? Mylar just fell out of the sky one day, literally, right?
Yeah, I know.
That came out of nowhere. That Mylar didn't follow the plastic advancement that we were going through. You know, you go from celluloid to Bakelite and natural rubber, and then you go into some simple polys, but then all of a sudden Mylar doesn't fit that bill.
Mylar's unique. I like
it.
Mylar.
Is.
Yeah. Yeah. I used to use it in my grow room. For food, people. For food. Okay? Get your head out of the gutter. I'm just kidding.
I'm in New York. You grow whatever you want here.
Yeah. Same thing with us. You can grow whatever you want. Doesn't matter. Nothing's illegal here.
I just found it rather funny that through some of the cheapest things you could do with stuff that was laying around the house, that was the best thing. Like, I got bought like hundreds of dollars with a high voltage line. It was junk compared to this stuff.
Yeah.
It wasn't holding it in. And I would start losing signal and everything. And by the time you got to the end of it, it was junk. You couldn't build up anything. So
that's why antennas use coax cable, right? Make sure that signal gets through perfectly.
That's right.
Nice.
It's a clean signal too. It's not a dirty signal. It doesn't degrade like that.
So my whole theory behind it was, if I have a room temperature superconductor and I wire that coax cable the way I have, does that make that coax cable a superconductor? Like, if I'm transferring the energy, like,
I don't know that it
all.
I don't know that it does. What I do know is, if you put a standard wire in there to do the pickup, it may start to glow purple on the outside. Okay. When you touch it, as soon as you touch it, you'll start to get purple to bluish glow coming off of it. Okay.
Yeah.
Just because your skin touches it. Now, if you use a coax cable, it won't. So now all of the energy you wanted, all you have to do is strip it back, take the center and put it right in there
Yeah.
to pull it out. And then now you have all the energy that you're producing instead of leakage.
Hey, this is a stupid train of thought, maybe.
Go
But-
ahead.
If you have a low loss coax cable that's acting as a conductor and you're sending frequency through it, and in that coax cable you were to have it actually wrapped up in fiber optics and then had a coherent light source surrounding your frequency, I wonder, I kind of wonder if it would skate with the light.
I don't know.
I don't know. That's an interesting thought. I don't think so, but that's an interesting thought.
Yeah, if you just had like a super, like a super clear, like whatever they use for that fiber, but rather than it be fibers, it could just be a sheathing on the immediate outside of the wire.
I know what you mean, kind of like a
Yeah.
coax cable. Like, yeah. I don't
Yeah.
know if that'd work.
And especially if whatever was used to put the light source through.
I'm not sure if it would work because in light, there's no mass in the sense there's no current, right? So I don't know if you'd pick anything up.
Yeah, that's where I'm not sure. It's
That's
one interesting dynamic of it would have to be the electromagnetic properties of the fiber optic material itself, because you would actually want some wave flux off the surface of the wire in order for it to take place. So if it was a pure insulator, it would probably hamper that effect. But if it had some dimensionality to it, where it was like a little wider and allowed for current propagation freely through it with the light source, again, this is just like a little bit of a mind thing that I'm doing right now live. So
yeah.
I don't know. I've never heard of that. So
Victor said a room temperature superconductor would have no resistance, so the field would continue with its oscillations indefinitely. Does that mean indefinitely without power? Or because when it comes to free energy, like everybody said it, and it's true, there's no such thing as a free lunch. You have to pull a little in before you can get anything out, right?
Absolutely.
But once you start getting it out, it's like a waterfall. You're turning on the tap and it just keeps coming and coming and it won't stop. And you're doing it for virtually nothing. Cents, if that. Yes, after charged. Okay. But a type 2 superconductor, room temperature superconductor, would act slightly differently, would it not, Victor? I'm not sure.
I sent him an invite to come in if he wants to hang out with us.
Yeah, absolutely.
yeah, I'll tell you what he's talking about right now might tie into something that he dropped in the chat regarding a new alloy nickel spin glass that they that I guess he had read a report on. I didn't have time to read up. Oh, look who it is.
It's Victor.
Hi, Victor. Is his mic on?
Can you hear us? Nod once if yes. Okay.
Yeah. I don't know if it's a superconductor, but it definitely acts as such. There's a lot of aspects of it that seem to be it. Once I get the system running and it's producing power and lighting, whatever load I have, my wattage is nil. Like I've lit a 1,000-watt electric element, stove element, maybe to about 75% or so off of 35 watts. That's not possible, right? But
yeah,
like
there's sidebar conversations to be had
yeah,
a little bit on this stuff.
yeah, I don't care. I put it out there. Like I said, it's been documented, and I've talked about it on other lives. So I got nothing to hide when it comes to these experiments. There are certain ones that I don't talk about, but very little. I let it all out. What are you gonna do? Shoot me? Been there, done that. Beat you in an inch of my life?
Hey,
Been there, done that. You know. Anyway,
by the way, when I told you that we were getting the transmutation on that scale, there was that second scale that goes right there with it. Okay. So it's the one we're not allowed to talk about. Okay.
yeah. Okay.
But it goes with the same thing. And you mentioned it earlier for the higher, you know what. So
Yeah.
I'm just saying that that's where it goes. So it fits right there. And based on how it's doing, it's building that as well. It's very interesting when you start to look at it as in, do you have basically one of your coils at the center of the earth, or is it two? And is it the sun that has two and we have one? It's an interesting question because the effect of two is different than the effect of one.
Yep, it is. Well, we'll see when that sphere is done.
Yeah.
I got an inclination this morning to wire coils to the identical geometrical form of each planet in our solar system. I don't know if I'm going to do it, but I got that inclination this morning, and I was thinking, you know what? If each planet's magnetics coincide with each other, and you had a coil that represented each planet, and you were able to achieve anti-gravity with your center coil, would the others in resonance literally revolve around it in levitation? It's just a thought, highly unlikely. Okay, maybe a neat experiment, maybe. But
what if each planet's in different resonance type? So say the one that's going crazy is almost in direct resonance with the sun. The one that's not going crazy is in sympathetic resonance to the sun. Based on when the sun shifts, is there a resonance that picks up secondary numbers, okay, in that earth? So if you have 21 frequencies, 22 frequencies inside the earth, okay, depending on which one the sun's putting out, it means that either you're in the right zone or wrong zone, which would change the Goldilocks zone, by the way, and it would completely change how we see our solar system if that was the case, wouldn't it?
you're too smart, Nathan. I believe that's exactly the way it is. Whether or not
These conversations been being had.
So if Saturn, what is it producing on the top of it that we're seeing?
yeah, it's producing a hexagon.
So does that mean that the sun is not necessarily in that same frequency right now? Maybe as we go through the calendar and we start looking, okay, we're in what, the year of Aquarius, okay, or the time of Aquarius.
Yeah.
So what if we're in one of the other ones? What happens to the frequency then? If the Earth starts to make different frequencies out of it and shifts based on an outside source, then what happens? Does that start to become something more? Is it start to coalesce back to a planet, okay, instead of gases? It's an interesting concept.
It is. It is. Huh. I don't know if I can prove it. Go ahead, Victor.
I was going to say, I think some of them charts he has that shows geometric forms of the platonic solids and all for lining up the planets. And we already figure that that's a crystalline structure that has a frequency.
Yeah.
If each planet has its own geometric form and frequency, then there is a way to push and pull. There's got to be.
So it'd be like a node antinode, so a positive, negative, or a North Pole, South Pole
Well, yeah, an
interaction.
attraction from one, repel from the Earth while attracting to the other.
Yeah.
So
That's
it's
kind
like
of what I was
pointing
thinking.
your vortex to the planet, tuning it in, and swimming there.
What if it's in F instead of F sharp? You know what I mean? Or
Yeah.
or A instead of A sharp. You know what I mean? There's a total
Less
different scale.
efficient. I don't know.
Create a threshold, open a door.
Well, that may be the difference between Venus and say Mars because one's hitting it right on and has too much power. One's not hitting enough. We're the one hitting right on the power side. Okay, so we're in the perfect spot, like the perfect resonance area. It could
You know,
all
chances
change.
are though, when in the formation of planets, there's a real possibility that that's just kind of how it goes, no matter what the star to a degree, where there's, you know, maybe not always going to be a Goldilocks planet, but provided that the conditions are right, things would be, more likely to fall that way, where you have the closest amount that being depleted, then you do have one place of equilibrium. Because I mean, no matter what type of interactions you're thinking about, it's all like these systems are always looking to find an equilibrium between the mass and matter and the energy in the system. So, it almost seems more likely that these ideal circumstances would coalesce as opposed to not. It seems less than chance. It just seems like, there's always going to be some type of major accumulation at the point of equilibrium between mass and energy in any given system. So I hate to say that because it makes Earth sound rather unspecial, but
It is what it is.
that's right. That's sort of it. There's always like that median point of interaction. Now, whether or not that's going to be a pretty place, depending on the variables, I guess that's the variable that would be determining whether or not it's a great place or not.
I got to show you guys something, okay? And I ran across it the other day. Check that out.
Huh.
That's the true color of Mars. Not a red planet after all. Not like they said.
I think
Look
like
at the face up on the left.
Yeah, looks like a lot of ice and trapped hydrogen stuck there.
That's
Yeah,
one
it's
big
just-
canyon.
What's funny is it's so much different than what they keep telling us. So all the pictures they bring back are all BS if they're all red out there. And this is what they're driving it on, that little rover.
Oh, the red is from our atmosphere, though. So
what, reflection or refraction?
yeah, it's got to go through everything. We got so much dust and crap up there. That's why our sunsets are weird color.
No, but I mean, that's from our atmosphere that the pictures come back red. Is that what you mean?
That's what I understand. Yeah, it's mainly our telescopes looking through our dirt to try to look at it. That's probably from satellite, right?
Yeah.
It's a
That
beautiful
was
picture.
they also said this is part of Carlson was that he actually took it with his own telescope as well, and it came out almost the exact same color.
That's crazy.
So, yeah. Sorry, guys. I just wanted to show that. I just thought it was so interesting because they always tell it's a red planet, and then they tell you it's a once supported life, and then it's like, well, it looks red. Why would it support life for people over there red? You know what I mean? And then you go, oh, well, it really looks more like an Earth. If you put a bunch of water on it, it probably looks just like Earth. Now it makes more sense.
Well, they sure are trying really hard to get back there or get there, whichever way you look at it.
Trying hard, I don't think that they are. Like, we
I
put
should
more.
say getting funding for.
Oh, there you go.
Yeah.
They want to get paid.
Yeah.
Can you find a magnetic picture of Mars? Because as I understand it, it was years ago. I guess they did some kind of survey of Mars and looked at it magnetically. And they said that like orange sections at one pole, it appeared to go north, south, north, south. This whole big area, just like sections of an orange were pulled. And I was like, well, that seems to me to be constructed.
Mm.
So do you want magnetic fields of Mars? Is that what you're looking for?
Yeah.
I would imagine that the magnetic fields of Mars are probably not all that strong.
Right, they're weak now because there's not enough
Yeah.
mass. Something happened,
No.
stripped it of water and stuff, so its mass decreased.
Yeah.
You maintain an atmosphere.
Yep, that's it. Can't maintain an atmosphere. That's what we were talking about when we were talking about the planets so much, was just you know, the amount of captured versus free hydrogen in any given system, you know? And if it's stripped of that hydrogen, it's in trouble.
So this is what they show right here.
Right.
It looks basically like ours.
Okay, well, this was pictures of actually the surface. They were saying the ground itself was segmented like an orange, and that the poles were opposing. And I just found that to be amazing. And then I never seen or heard about it again, so I kind of spaced it off.
No.
Wow.
Oh shit.
Opposing poles, that would be crazy. That would be almost like anti-gravity on the surface. No?
Well,
Well, they
I
don't.
believe they're all constructed. I believe the planets are constructed. There was some big war, and we're being towed somewhere.
Well,
Well,
hold on.
I definitely think there was a big war, a scalar war.
Yeah, I don't think that they have enough mass on their moon. There's 2 moons, and there's not enough mass in total to 1 in order to get your tidal effect that you need to pull the water out of the core of the planet. So you're not going to get a pumping action out of it. You're not going to get that water to come to the surface. It'll stay frozen underneath. There's no push-pull effect on to heat it up. And as soon as there is, then the magnetosphere will grow. So whoever thought of putting nuclear weapons to the Mars is a moron. Let me just put it that way. And then whoever thought of let's go on there and let's just create a bunch of industrial plants and put smog in the air, you are also in the moron category. Okay?
Part of the moron category.
Yeah.
Pre-moron. No, I'm just kidding.
Just seriously, man. Like, come on, you got to have more than that. I'd rather have a Death Star running around it. You know what I mean? Than this.
Well, I mean, not for anything, not, you know, like it might benefit from thermonuclear weapons.
Oh yeah,
We
didn't-
might.
we didn't want to live there anyway,
Joe.
Joe. Yeah, we just didn't want to live there. But you're right.
Well, here's the thing.
We wanted glass, and we
If
didn't know how to create it.
it's a fusion hydrogen bomb, and you let enough of those go off, I mean, it's possible that you end up, you know, creating a burn, and then capturing enough hydrogen in the, you know, to condense and form an atmosphere, possibly. But I don't know. You'd probably blow the planet up before you got there, though.
Yeah,
I don't know.
I don't know. I don't think it's a good idea. I'd like to grow crops on it one day. One of the things that they said also with Carlson was that that the actual soil is fertile, so that it's good to be used.
That's interesting.
And then he says the one side of it we don't see, which I don't know how that's possible, is actually blackened. And then one side's filled with all the sand. So I don't know that would be right because Mars rotates, and obviously we'd be looking at the rotation and full understanding of Mars. So I don't know how that's possible. Okay. But I got an idea. Why don't we just launch a satellite and put it around Mars? Maybe a couple. Maybe take a few hundred that we have here and just ship them over there instead of, you know, guessing about it. Why don't we actually CIA the thing and we'll just look at it all the time and we'll figure it out. It'd be better than that little race car rover they got.
It makes you wonder why they don't, right? Drones are cheap in comparison to those satellites. Why not set up a bunch of satellites, drop the drones, have it send a signal back to a satellite, back to us? Like, we could be monitoring that planet all the time.
The problem with that is the we part of it, because I hate to say it, the we ain't me and you.
Well, no, I get
Pay
that.
for it.
So I mean, you know, It's going to be the same numbnuts that tell us that none of the stuff we're talking about is true or correct.
NASA,
So.
never a straight answer, right?
Can I go Google
yeah.
for a minute? Have you guys heard the legend or the story of how I don't know if it's the Ganges River was formed over in India? I think it's the Ganges.
I remember hearing something. There's
Yeah,
a legend behind that, isn't there?
Yeah, there's like a god let down her hair, and all of her flowing hair was like rivers. And I guess it maybe connects to the flood myth. I don't know. But I had like this weird vision one day thinking about that when I was hearing that story, that something happened, Venus and Mars and another planet, you know, in a big destruction, and we had stargates. And the people on Mars knew they were going to get wiped out. So we opened up stargates, and they came here with as much of their water and oceans as they could. And that's how we got things like octopuses and cuttlefish that are just totally strange. And we're trying to get those gates open again so that the people that lived there can go home, because they've been considered a lost tribe or whatever and don't have a country. Well, they had a whole planet, but they got fucked.
Yeah.
I don't know. That's just something that.
Well, I told Nathan a cuttlefish came to me in a dream,
A cuttlefish.
and then I gave him about an hour and a half of his life that he's never getting back.
Yeah, he did.
Yeah.
That's certainly possible.
I think cuttlefish are cool.
If you want to talk about like the growing aspects of this stuff, like you were talking about the other day,
Yep.
you know, about like it being, is it biological? Could it be biological? This, that. Cuttlefish is a pretty good place to look, because I mean, if you do want, you know, it's,
I don't know much about them.
well, I mean, they can't see color, but they have active camouflage that they could change. That's literally animated the color of their skin, and they can't see color, yet they accurately can pick up the color of what's underneath them. They could also change their colors to any color under the rainbow just from the luminosity of their skin. But I thought that was the most interesting part about them, but it's not. Turns out that they have a bone that no other animal on the planet has. You know, and of course, us being humans and stuff, since we're so smart, you know, we pick these bones up off the beaches, and we sell them in the pet store for people's birds to eat. But they're cuttle bones, right? So the cuttle bones, they're almost entirely made of calcium carbonate. Okay, but they're in a crystalline lock structure, all right, of cells, and these cells have ionic exchange through osmosis of the water, and that's what controls their buoyancy, is pressure differential.
Really?
So, you know,
So there's something to see with the cuttlefish. That's
it's a ballast. And when I was talking to Nathan about this, I talked about like an issue that I saw in my head with the whole coil system, but he's like, no, it's really not an issue. I was like, well, let me just get it out anyway, and then we could just throw it in the dumpster. It's fine. You know, no harm, no foul there. I was like, if you synthesize a cuttlefish bone, okay, into a conductor and semiconductor type lattice material, okay, where it acts as it would act as like it would basically leach off all the excess energy and hold it and put it as a discharge to the outside of the craft, okay, anytime it's in excess, but then be available in that sponge to then give it back, you know, to the coil system if it was pulling too hard. So it would act as a purge sponge, and it was all based off of the cuttlefish bone because of the structure and what it is.
Wow.
Because it would hold that pressure differential. It would actually give whatever the need is. If it's more upward or downward,
Down. Yeah.
you know, and then it would purge it off to the side to keep your bubble going and strong, and then it would give it back if it needs it. I don't know. So again, that idea went in the dumpster, but it was off of a dream that I had about a cuttlefish. Yeah.
It's more like a working system.
Well, hey, you know Mike Battery, when he's talking about it,
Yeah.
and he talks about when he gets closer to it, puts his hand on it, and he gets more energy out of it.
Yeah.
It kind of reminds me of putting an outer shell on a ship. Okay, that you would have it to charge it and run the thing, but then when you go near it or have it come in combination with some kind of other energy source, it'd probably be able to pick up energy from it. So if you're up in the upper atmosphere, you can stay there for a very, very long time because it's able to soak in the extra energy that's up there. And then it basically runs its own system and you don't have to mess with it. So you wouldn't need more mass and you wouldn't need more fuel and you wouldn't need some big gigantic atom bomb to turn it on. You wouldn't need any of those things.
And in space, you wouldn't need coolant for your superconductor either.
Nope.
Nope. In fact, you would flip a switch on your system in order to create heat once in a while.
Oh, yeah.
Mhm.
Need some heat up there, that's for sure.
Yeah, that's what you need. It's the opposite problem. Earth people problems, you know. Maybe not in Canada, but
I just ordered a few things when it comes to heat. I'm going to show you guys hopefully in the next month. I just ordered a couple of tubes and some other materials and show you some cool stuff that's going on with the coil. The next stage. And then the alternator's coming out soon too. Works in reverse.
Did you guys watch that 437, 427, whatever it was that I sent you guys? The link?
Not sure.
I don't think I saw it.
All the
400.
last graphics you sent me were all gray. All I got was the email links to Straight and Mr. Lanius.
Oh, Mr. Lanius guy, he wanted me to forward you that, so I did.
Yeah, but all the pages you sent me just came through as gray nothings.
Oh,
That was
I
weird.
don't know why that is. I sent him the same way I sent Gerald's.
Yeah.
So, well, that sucks.
Could be my internet or someone don't want me to have it. I don't know.
Give me a second. Let's see if I have it here.
All I got was one picture.
That's all you got?
Yeah.
Okay. By the way, I want to show you guys this. This is somebody did a crop circle and it reminded me of the Merkaba.
Oh yeah.
You know how he runs his system, right? He's got the ball magnet in the center. He has the whole thing is lined out so it builds the Merkaba energy in the center, and then he runs a frequency which is a sine wave on each one of them. Okay? So it looks just like how you would run his system from that crop circle. So I thought it was just amazing to see it.
That's really cool.
That's showing how to create a sine wave. There's so many symbols in there. There's a cube. There's like, wow, man, the angles.
Yep. Cube, pentagon. Yeah, man.
There's
It's all there.
there's a tetrahedron in there. There's a, wow, that's crazy.
Speaking of that, Victor, while I have you, what do you know about that? The nickel spin glass.
Oh, I was kind of waiting until we could hook up, and I didn't have your email to get together. And
Oh yeah, well yeah, we could link up.
Because
Yeah,
in the same article, there was also a new superconductor that looks like a pine cone, and they got that thing glowing. So,
Pine
man,
cone, huh?
yeah, I thought that kind of odd.
That's kind of funny. Wasn't there a pine cone inscripted in Sumerian text? I don't know. Just a thought.
But yeah, the magnetism in spin glasses and the way they're working with quasi crystals and incommensurate geometries.
You
There's
realize
in this book I wanted to share, but I can't seem to find the page. I just have all my stuff yellow, what do they call that?
Post-its or whatever. Yeah. Man, I need to start using them because I have so many things that I always want to like hold up to the wrong side of my phone, and then be too dark for everyone to see. But like, it's easier to find in my head than it is in the damn books because every one of these books is like 300-400 pages all the time. You know?
Yeah. Do you guys realize that these coils are actually a form of metamaterials?
Did not know that.
When they're geometrically sound 180 degrees out of phase, they're a form of metamaterial because they act almost like a fractal.
Yeah, well, it's a macro metamaterial at that point.
Yeah,
So check this out. I don't need any comments on it. I just want to show you guys this. This is part of what I was sending, so I don't know if you guys got it. Okay, but it goes to something I told you earlier, Gerald.
Yeah.
It's right there, isn't it?
I didn't see it. I see it now.
I can't talk about it, but it there you go. So now you understand, right?
Yeah.
Mm-hmm.
So
Restructure the ladder.
yep. Well, so I tell you, there's overlapping things in there, and there's a reason why I say they're there. And I'm nobody's special scientist here, but I do understand where things fit. Okay, I do get it. So
Yes, you do.
10.
You do get it.
I'll show this once and only once. The Bible stands for
nice.
And by Bible, he means in the acronym Bible, not
By
the
the way,
alt text.
We're not allowed to.
the Bible.
We were told yesterday about religious stuff. We weren't allowed to talk about it, and then we're not allowed to talk about medical. So
It's a Bible.
yeah, just so
You
you
have a
guys
bit?
know.
You got to put on the bib, the Bible. Bible. Basic instructions before.
Yeah.
Yeah.
What I find is so ironic is every one of these is starting to show you something like they broke down the pieces and they never put them together.
Yeah, just like they do in with the subject that we can't talk about. They,
The other
they
subject.
make certain things, they break them down to their constituents parts and say, this is the thing that you need. We can't elaborate, but I'm sure our audience is intelligent enough to get it. We have a very smart audience.
Yes, we do.
Well, here you
Yes,
go.
we do.
Breaking it down to different parts of it and how they interconnect. Now, you probably wouldn't realize this if you didn't know what it was. This looks like a pretty picture, but there's more of an understanding here of how it works. So,
Yeah.
Anyway,
Yeah, look, you're really outdoing me there, Nathan. That looked way better than the mushrooms. Listen, it told the story.
well, I do study, and when I study, I tend to get things right. You know, not that I do it all the time, but
You do, Nathan. I gotta admit, man. You're
Man, you're on it.
on the ball.
I don't know there's not a physicist out there that would try to talk you under the table and be totally wrong about it, that even puts in half the time or effort that you do.
Yeah.
You know?
You should be a professor out of a garage.
you never
should.
know. As soon as I get Ben's lab coat, I might become Professor Nathan Oldman Builds right there.
Well, then you're gonna get 2 lab coats. You got one coming for me. I got one coming for each of the team. I'm just getting the printing done to it right now. So
Well, I'll have to apply for a scholarship because right now the tuition funds are a little light.
yeah, I hear that. Our tuition fees are faith, or can we even say that?
Oh,
Yeah, it's just a matter of wanting to understand. That's your tuition fee.
well, I think it's funny because they talk about physics like it's some beautiful sunlight in the middle of nowhere that nobody can achieve. And it's like, dude, it's a few sentences. I could take down a few sentences and then I can go in and look at the symbols and see what the math says. then I can simply take one or two little classes online and I can figure out the math very easily. It didn't take that long. All you're doing is taking symbols, putting in a value to them, or you're putting it in an equation form. Then all you're doing is simple multiplication and division. You know what I mean? Is it really that difficult? And then, oh, I'm sorry. We got to push the sine wave button, the sine button. Whoop. Okay. Or another one, oh, that was too hard. Oh, got to push the button that says graph. Got it. I got me one of them, expensive calculators. And you're like, give me a break.
So tell me
people
something.
aren't at the point of realizing the value of what's being brought to the table here. Okay, because it's like that old story is, the nuclear reactor broke down. They brought everybody in to try and fix it. Nobody could figure out what went wrong. And they said, all right, call the guy. And the guy walks in, looks at it, goes, and taps it with his hammer and then hands him a bill for $1 million. And they go, $1 million? What are you, out of your mind? All you did was tap it in the hammers. It's like, yeah, but I knew where to tap, man. Like,
Credentials you're paying
that's it. Like, that's it. But it's that trust and value there,
Yeah.
You know what's funnier part about it is? They say a theory which has all the math in it. So then they refer to the theory instead of doing the math again, right? So now there's these little segment lines that just cut here, paste here, and then that creates that theory, okay? That's why this one gets cut here and this one here. And then when they do the math on it, it's wrong because now they're trying to tell you how the flow of the energy goes instead of looking at someone like Steinmetz and saying, oh, that's how it works, okay? Then they always create new math that doesn't work.
Okay, hold tight. Blow your mind right here. They do the reverse of what actually makes it work.
Yep.
They do
Usually,
the reverse of what actually makes it work. Because, see, they find the differential, okay? And then they're like, wait a second, it doesn't add up. So then they create the equation that adds up to the missing differential, and then that's the new math that's in there. They don't know why, how, and don't question it.
I gotta admit, this is going to be a question from somewhat of an ignorant position in my life. But has there been anything that has come out of the world of theoretical physics that has actually benefited mankind, other than Einstein? I know everybody touts Einstein like he's some kind of god. He was a potato farmer who was intelligent. Give me a break. Just like I'm a farmer who made a coil. No big deal. You know what I mean? But
I could answer that, though. The answer is yes, because there's more value in seeing what's wrong sometimes than seeing what's right, because then you know exactly what it isn't.
Okay, but isn't the point of theoretical physics to come up with the theory to fix the things that are wrong in today's society and life, even though they're not?
No, they're trying to break it down to the smallest possible part to understand it at that level and then see if they could break that part down even further. And then I guess that once they could see what every ingredient is, eventually, then they'll try to make sense of it. That's why they haven't figured it out yet.
Yeah, science fractalizes everything, breaks it down, like you say. What can we pull out here and sell? And then how do we get rid of this waste?
Yeah.
Sometimes, it's okay to do that, but rather than break down to the smallest part, sometimes it's just easier to break down to simplest form, and that's inherently different. Simplest form is different than smallest part.
Yeah, I got a question for you. With the Manhattan Project, right? And they're the Demon Core, okay?
Mhm.
Yeah.
You place in too many things to the core, okay, the outside part. But is there a field that's there that's creating energy? Okay, because we know they're breaking the atom in half, but they always want to put atoms in the wrong place and not fields. So was there a field there that created the radioactive part that killed all those people when they dealt with it? Okay. So, or is it an atom right there? Because to me, it seems like they put it in there and it created a condensed field, which made it radioactive, which killed a bunch of people. Okay. So,
Well, I mean,
Where was the
yeah,
atom?
the wording's a little dicey on that, but I would say yes. It's not. It was a field event.
Yeah.
A field event. You know, where the mass the energy ratio of that particular area, when it came too close to critical mass and started chucking the goods
Too
fast.
much energy at the wrong frequency made their heart stop.
Yeah.
Basically, right? That's the experiment you're talking about, the demon core.
Yeah. So my only thing with it was not what it did, because we know what it did. It was it a field or not? Okay. Because you're compressing a field right there. And that's the way I look at it, but maybe not everybody does. So is it electrons? Is it atoms? What is it? Okay.
I think
Or
it
is it
was-
just a field?
Well,
I
I
think
think it's a field event.
Yeah.
At that point, yeah.
Almost like an EMP with a field, right? It literally compressed and went whap, and just
Yeah. So,
Like what we were
a
talking about with
strong
Mike.
pulse followed by a diffuse overall radiance until they unscrewed the mess.
Yeah.
And
that's my thought. I don't know. I'm no expert, but yeah, definitely.
I mean, well, really, what's a field? I mean, a field is an area where there's an emanation event, and the stretch of that emanation event. That's really what a field is.
Mhm.
So yeah, I would say it's a field, but could you look at it at the smaller level and then say, well, yeah, it was actually just throwing off all of these particles? I mean, you could say that too, and on a one-on-one basis, that would be correct. But as a whole, the whole entire sphere was doing that and externally propagating outwards. And you have a lot of the same type of reaction propagating outwards, creating a field.
I would say two fields, or yeah, two interacting fields creating a series of nodes, which some would consider particles. So essentially, yeah, it would be a very strong multiple frequency, multiple bandwidth field.
I wouldn't want to be anywhere near that.
Nope. That's crazy.
Make
Yeah.
sure it runs at the right frequency, or else, things we can't talk about on the other side.
Yeah,
That's
frequency is so much stronger than they give it credit for. I mean, seriously, how do you take down a bridge with just frequency? I mean, that amount of energy, it goes against all of their laws in physics. Okay? If you have horses on a bridge or you have people on a bridge, right? And they create the same redundant frequency again and again and again, you start to see the bridge swing. Okay? And eventually it'll fall down. How is that so? Where's the conservation of energy there? Because you didn't put in much energy. You did put in the frequency, but you resonated it continuously. Okay. So that doesn't equate in the physics scale. It breaks. One of the few things that'll actually break the conservation of energy.
Yeah.
Yep.
That's why if you get onto some highways, at least by me, like at certain entrance points, there's like a red light at the end of the exit that will tell you green, go, because it has traffic counters and stuff down the roadway. It could tell how many cars are coming, and it won't give you the green light, if you're going to go over a structure or whatever, because it can't have too many cars going over it, like you just said, like the people or horses or whatever trotting across the bridge. And it made no sense to me until I realized that factor at some point, because I was like, how come it's 1 o'clock in the morning? There's barely any traffic, and I'm sitting here waiting for this thing to turn green. Yeah.
So hold on real quick.
Are you aware of the Tennessee high school kids that did a test with sound and found this kind of square tubing thing they made? And they proved that sound travels faster than light, and it will actually travel through space.
Really? Didn't hear about
That
that.
was Tennessee. I I don't know. I'd have to go look it up. But anyway, they found a form that's kind of like a trumpet, sort of. And when the sound waves go through it, they're somehow faster than light.
Makes you wonder about the ram's horn and the walls of Jericho.
Well, if we're
Right.
spoke into existence, then sound is the thing. And there was a man in chat that said his dad did it with sound. And remember that rotating aluminum cylinder on the physicsworld.com?
Yeah.
Where they could get the magnetism to wrap around and boost the magnetic field just by a rotating cylinder. They did that experiment first with sound waves and proved it there, that they could get it to amplify. And so they thought, well, if we can do it with sound, why can't we do it with magnetism? And then hence the rotating aluminum cylinder. Well, there was a guy a long time ago that said if he built a gigantic cylinder and rotated it, he could, in essence, have a wormhole tunnel type device. So it's probably been around longer than we're aware of.
Okay, I got to ask this. We had Todd in the chat, and I just want to ask him, okay, is there any math for cold electricity or negative? Okay, because I haven't found it yet.
I don't think there is.
Well, you might have a link, and I'd love to see it.
He might have
So-
come up with it himself. Never mind. Todd's a smart man.
Yeah, well, I agree with that. So it's undefined. There you go.
Grebennikov, I haven't heard of that name in a long time.
Yeah, Grebennikov was a cool guy.
Yeah, he was
Oh.
smart.
Guess what my brother found for me at a book at like a Goodwill? He just goes, I don't know if you want this. He says, I saw it and I thought of you. Is it Vallone? Forbidden Science?
Vallone,
What is-
really? You have
What is
Tom
meant by
Vallone?
cold electricity?
Tom Vallone? Forbidden
No.
Science?
I should probably go get it because I haven't even started reading it.
Tom Vallone was an experimenter.
It's, Actually, I should go. Whoever wrote Forbidden Sciences or Forbidden Technologies, was it called?
Forbidden Tech. I think you might have heard of that one.
Yeah, he goes, well, I just thought of you, and he gave it to me, and then I ended up
Interesting.
going and looking for some books and found a couple of nice books myself. Like I found a copy. I haven't just perused it. I haven't read it yet, but I found Morals and Dogma.
Oh, wow.
Books.
No kidding.
Yeah, and then I went online and I thought, well, hey, I thought this book was hard to get, and I looked on thrift books where you can buy used books, and they want $185 for that volume.
Really?
Yeah, I was like, oh my gosh.
I'll tell you what I was telling Nathan before we got on the chat. I just got back from Salem, Massachusetts with my family. It's October, so we took the drive up there to go do the Halloween thing. And I'm like, oh, nice, lots of occult stuff I could look at. It's like, see what I could find. And, believe it or not, it's harder to find like any sort of original or rare books or anything like that. They're selling to the masses for things that I don't dabble in, let's put it that way. But one thing I found interesting was right there in the Witch Museum, where they went over all like the accusations and everything that they did back in the day. And in their museum, they had the first volume and the second volume of the originals of Secrets of the Unseen World, written in like 1690 and 1700 respectively. And I was like, and they're in a glass case. I'm like, I need to open it. I like go open and read these books right now, because evidently what ended up happening was they did what they did over there, but then they quickly realized their mistake, stopped doing it, and then buried all the evidence that had ever happened, and it lived on through like word of mouth mostly. because they actually, they weren't America then. They didn't have freedom. They were like, anything you have that had to do with this has to be like burned and gotten rid of. Period.
Yeah.
End of story. That was and never spoken about again. They wanted to sweep it under the rug because they knew they just killed a whole bunch of innocent people. And long and short, those were the two books that kind of prompted the whole, what are we doing? Oh boy, this is a big mistake sort of thing, because there was science involved in it. So I was dying to know what like the deep and dark of those books were, but I didn't have time to research it totally to know what the availability looks like. But I'm going to go out on a limb and say that it's not going to be easy to even get copies of those manuscripts.
Right.
Well,
Bernie, I haven't even read the book. Like I said, I think I looked at a couple pages and I'm like, well, I don't know what to do with this yet. And it just sits on my bed.
if I had one of those books, Victor, I would do a live reading and read the whole freaking thing out loud.
Actually,
I don't give a shit about their.
I
Sorry.
felt
Wow.
like taking it to the Masonics and because the man who apparently passed, his receipt was in there for buying the book. I
You
just
got a
had the
lot to
feeling that
find
I should go ask them, how do I use this? But there's been
They
so much
take it from you.
controversy about them that until we saw that one video, I don't even know if I trust or want to get into it. But
You know what? I
Curiosity
can get
did
into
the
it. But
cat.
I don't want to get Nathan into trouble, but that book is what most people have controversy about that group entirely over the whole internet. That book would literally prove maybe half of the conspiracies that are out there just by reading it. That's why what Bernie said they believe, because that book tells truths that they don't want the public knowing. If I had the money, I'd buy that book off you myself, Victor.
Maybe that's why it's still just sitting on my bed.
Hmm.
I just had a
Damn, you're
feeling
lucky
that
man to have it.
My
I'd be
grandfather,
exposing it.
my
That's just
family
me.
has Masons in its line, and there's supposed to be someone stole the family Bible and stuff, but I guess there were extra little books that explained it all. And that's why I figured, I don't know how to use it because I know there's more than that book alone.
There's a code in that book. That and two other books
It's
interposed.
hardcover.
There's certain, if you put it together, literally unveils secrets that you couldn't even imagine.
Whoa, are you kidding me, Bernie?
No,
The thing
that's-
is, it's like with any of this, you got to remember, information is the best thing to have, and it's all what you do with it. You know, so
Tell it to me, Victor. I'll expose it. Let them come for me. Just kidding.
No, are you
do
serious?
your
Bernie?
It's
effing
totally
presentation first, Gerald.
That's what I meant by half the conspiracies on YouTube. All would be either null and void or confirmed through that book, because what Bernie said at the end of that sentence is exactly what that book contains. He actually, the guy who wrote that book, stated it in a letter to somebody who's important, apparently.
You
So
mean the plan is in there?
the plan is directly in there, exactly putting Muslims, I shouldn't say, I'm sorry, putting certain factions of people against other factions of people throughout all of society, different factions, different religions, different beliefs, all against each other in order to create a separation, in order for something to happen so that they can build things up in their own image. That's what this
So
is
they
all
could
about.
create chaos and come in and bring the
And
order.
that book literally states it in their words. That's why it's such a big deal that people don't want anyone to have it.
Well, that's the nefarious side of things. Is that's black? That's by definition black magic.
Yeah, that too.
Wow.
That's how magic works. What's said, people think magic's like, whatever, but no, magic is science and psychology combined into each other
With the intention
with
behind it.
with intention behind it. Yep.
Yeah.
And good intention, bad intention, your call.
Yeah, I studied it when I was young so that I knew what not to play with and knew what people were playing with it. And yeah, I know a lot
Yep.
about it.
Because all magic is manipulation. That's all it is.
psychological manipulation at a level that's personal. That's what it is.
Mhm.
Sick, but to each your own. I personally like dealing with people one-on-one. Why would you want to manipulate somebody for your own benefit or some stupid thing that you want to get done? Like, really? Ask. Quit being such a lame tard. Sorry.
So I just wanted to say this. Todd was in the chat earlier. Todd, if you're still out there, all day tomorrow. I got it. You want to come on, discuss your paper, talk about anything you want? I got all day tomorrow. So you just tell me when. So I've been doing my due diligence. I read it several times, man, and went over the whole thing. And I think I have a firm hand on it.
I'm going to get some coffee real quick.
Okay.
I'm kind of
Genetic
feeling like
job.
I should have kept my mouth shut.
Yeah. Yeah, I'm gonna go grab something to wet my whistle too. I'll be right back.
Their system's already in play, Victor. They don't give a shit anymore.
Right on, Todd.
Genetic
excited.
Jabber brought up
Yeah,
Order
really?
of Chaos. I have that book by Pergurni or Pergurni. It's an interesting book.
What book was that? I missed that. Sorry.
Order Out of Chaos.
Oh.
Yeah.
Mm-hmm.
Interesting book. Read everything. There's no such thing as bad knowledge, just what you do with it.
This episode brought to you by C4, 300 milligrams of caffeine.
We're all going to get in trouble now.
It's a commercial.
Yeah.
Yep, free plug.
We don't do commercials. Not on this show. I'm messing with you, Joe.
Oh, I know.
You can get this nice tumbler for $5.99. No, I'm just
No commercial unless Ben does it for his jacket. His lab coat.
I still
Or his
think,
hard hat.
listen, we might have to have rivaling jackets. I still think so.
yeah. Maybe we'll.
Woo 1, Woo 2, Woo 3.
That's it. The Woo Crew. We should do a live like that. The Woo Crew.
Oh man, I got woo for days.
Yeah, we all do. I think.
That's terrible.
Seen a lot of woo. I don't talk about too much woo. Yeah, when I was 7 years old, that was 5 actually. But when I was 7, that was the first time that the woo kind of helped me save a life, and it's crazy story. Yeah, through the ice, the whole nine. I've talked about it in previous live though. So,
Have you ever seen the TV show Manifest? It
Yeah.
used to be on, right? And then it was on Netflix. It finished off.
yeah, I watched the whole thing. It was interesting.
Makes you realize that there's people out there that they know things too. Lots of people know things, and they let it out little dabbles.
I believe, and I don't think we'll get in trouble for this, but I believe that in the 1940s, with Tesla and Steinmetz and everybody's work, I believe they found this tech, and there's a breakaway civilization sitting somewhere that we don't know of, because this tech didn't just stop, and they didn't just give it to Mike, the military industrial, right? They didn't give it to Mike. So what? Yeah, the military industrial. Because what are they going to do with it? Just bank it? Just like let it sit for the day that they need it? I believe there's a breakaway civilization.
Well, honestly, I mean, that's pretty woo, but at the same time, that is path of least resistance. You don't have to worry about all the conundrum around, like, well, what's this going to do to society? Who's going to come after this, that, the next thing? If you just say, you know what, we got it, let's go.
Yeah.
That's one way around it all, isn't it?
So hold on. Would that be with the Admiral Byrd and what is it, North or South Pole?
Yeah, that's South Pole. But Agartha, you're talking about?
Yeah.
Yeah, it's possible.
Where the other word that we can't say, they were down there.
Yeah.
Yeah. Yeah, you know what? That new coil that I'm building might actually shed some light on that very subject. Just because of the way that it operates, if I'm right.
That'd be cool.
Yeah. It would be very cool because the inside's an open cavity. and there'll be a field in there that's different than the outside field of the whole sphere. Plus, there's going to be a magnetic concentrated sphere in the very center where the null zone is, or where it's supposed to be. So it's going to be interesting. Mm-hmm. If it works the way I believe it will, it might actually prove that the Earth is possibly hollow. I doubt it, but maybe. I don't necessarily believe it's a big chunk of iron spinning in a freaking circle. I'll tell you that. I don't believe that at all.
Yeah, no, I don't know about that.
I think there's a lot of Swiss cheese going on there. You know what I'm saying?
I think it's a giant crystal that's actually resonating and resonating with the other crystals and every other planet in our solar system. And I think because of that resonation and the magnetics and the way that things work, it's creating spin on our Earth. It just happens to be slow because our Earth is very large. And I think there's a counter-rotating spin on the inner Earth because of that crystal sphere.
I still think Saturn and probably Jupiter too have diamond cores.
Yeah.
My train of logic ran me right to that conclusion. I was like, too much free hydrogen, not to have severe depletion. What? Oh, everything else got carbonized under that much heat and pressure. What does that create? Diamond. What is a diamond? It's a cubic mineral,
Yeah.
and now it's and then how does that manifest on the surface?
Uh-oh. His Highness took the transporter. Better make sure Mike's okay.
I want one. I want a transporter.
Oh man, wouldn't that be the coolest thing? Like, I think I'd get really fatter than I am. The transporter.
I
You
think
have
I
to-
would too. I'd transport to the fridge and back. What do you mean?
I'd just do it. Yeah, for the heck of it.
Yeah. Yeah. Somebody brought up Dan Winter. I've studied his stuff when he first came out. With all due respect to him, he does good work. Not quite on the ball with that one, but teach your own.
So I got a question for you. If you create a singularity in the center, what does it do to the outside? So, like, if they say, okay, you got a sun outside, in the solar system, but you got a sun in the center of your planet. Let's put some theory behind it. If we create the singularity in the center, and that's like a sun, okay, then does it produce the energy in the center? Then you get a rotating, like lava around it? You know what I mean? Could that create a magnetic anything?
Honestly, I think that this thing, if it was spinning at a high degree in the center of the Earth, it would create like an anti-gravity field around it, almost creating its own atmospheric potential to the point where when mass started forming around it, or who knows, maybe the mass was there and the crystal formed after it. I'm not really sure, but I think it would be a shell that surrounds an inner cavity, like what you were talking about earlier, the Kashmir cavity, and then the sphere would sit in the center and spin, not unlike a Rodin coil or not unlike the Merkaba, right? And it would spin and keep the oscillation running as the field is literally perpetuating that spin as well. I'm not putting it into words properly, but it's kind of how I think about it. It's a field within a field within a field in opposite directions, right? And that's what creates our electromagnetic field for our Earth. I could be way off, but
That would be like a lot of torsion at those points of,
absolutely.
like extreme amounts.
Yeah.
Incredible.
Yeah.
Hey, look at what it is.
Hey, Mikey.
What's up, Mike?
What's going on?
Not muck and fudge.
Yeah, we're just whacking out on Saturday as usual.
Yeah.
Not off, out.
Yeah, I was gonna say language there, dude.
Uh,
I love it. That's funny.
You should have seen what he said last week. Okay. We're over there. What were we talking about? Something. And then he started talking about a hole and then playing with something.
Oh, the muff diver.
Yeah.
the muff diver.
I'm trying to keep a straight face the whole time, and I couldn't do it. There was no
Yeah,
way.
what an incredible contrast from science to muff dive.
Just turned a knob. You know?
Hey, people have to swim. Okay, I mean,
I think we've been exposed to too much electromagnetic radiation. Maybe that's why we're kind of losing our marbles every now and then.
Yes, I've been along for a long time.
yeah.
Oh my God. I couldn't believe that. That was outrageous.
Well, he's not drawing circuits, at least. That could be bad.
Oh, only you, Gerald. Because he did it again today when he drew a circuit.
I know. I raced it and went, no, that's not right.
Did he smoke it or?
I need to give Gerald a sensor pad so that every time he draws a circuit, he put it over half.
That's great. Yeah.
Yeah, so yeah, I just did some shopping this morning. Had to go to the pottery shop there and pick up some silicate carbide for my power cells. So drove down there, got that done, and then my wife yanked me over to friggin' Costco and had to spend some money there for Thanksgiving dinner tomorrow.
Oh, yeah.
And now I'm just kind of flaked out on the bed talking to you guys.
Well, I hope you got some Red Bliss potato salad while you were there, because if not, that's like a sin.
Well, we get it all the time. Like we always buy it when we go, especially like in the summer, because we do a lot of camping and stuff. And that's like the thing to bring on a camping trip, right?
Mhm.
So,
Buy potato salad? You don't make your own potato
Listen,
salad?
I usually make my own, but that Costco
Yeah.
potato salad is really good, man.
yeah, the Redskin, yeah. And what is it? What size container is that? I think it's like a liter or something.
I don't know. You guys don't use the same measures over there as we use over here, so
Yeah, it's a big container, like like the same size you would get like ice cream in.
yep.
Do you guys
Bucket.
put apples in your potato salad?
Apples.
Green ones are good in there, I'll tell you.
I've done it. I don't usually have it. I'm just kind of old fashioned that way, but
I hear you. It's a nice little treat if you're doing something like you want something different. You still want your potato salad. Chop
You
it
know
up really
what?
fine little cubes. It's
no,
tasty.
like I've had like apples and like just like a regular salad with sunflower seeds and stuff like that. That's actually really good in a regular salad. And then
Really?
I make a really good like oil vinaigrette dressing. It's kind of like a family secret thing, so I do that. Usually everybody likes it when they have it. So
Did you have to sign an NDA on that?
yeah, really.
That
yeah. You're born into the family. You're born into the NDA, right?
And at least the recipe didn't find its way of Victor's family Bible, you know?
There you go.
Yeah.
So Johan Reeder, there is no hollow part in the earth. Well, I sit corrected. Like I said before, I wouldn't know, just a theory.
Yeah, there's actually, Gerald, you were holding up some books there earlier. Another one I kind of recommend is called The Cult of Ether Physics. I think I mentioned it once on the show before,
I think
by William Lynn. And he's pretty on the ball with this stuff. I'm not sure if he's alive still, but he did do a volume 1 and 2, Cult of Ether Physics. And actually, Eric Dollard actually endorses the book.
Is that
Yeah, the
what
book's
you-
been out of print since '88. It's a little hard to get.
Yeah, but there are reprints of the book. A friend of mine actually was able to get it somehow online. He got both versions of it, and I was able to sift through it and take photos and stuff like that of certain things I was looking into. But
yeah, my
that was-
order out of. Sorry, Mike.
no, go ahead.
I was just gonna say my Order Out of Chaos. That's a used book that I bought from just somebody that does the Amazon thing, right? So
Right.
you can get lucky here and there.
Yeah. You just have to search around. There's so many different venues that you can find these books, right?
Absolutely.
Actually, I got a little collection of my own. Let's see what ones I got here. I got a couple of Tesla books. Let's
Mike?
see.
Did you
Yep.
say the last name was Lind? L-I-N-D?
No, Lynn. Lyne. Yeah.
Oh,
Cult of Ether Physics. Now I got this other one here. I still yet have to read it. Hold on a sec. Let me just change my camera settings here. Bear with me here for a second. Yeah, I got this one here. The Histories and Theories of Ether and Electricity by E.T. Whitaker. That's a good book. Yeah, E.T. Whitaker. And this is a big book. Hold on. I don't even know how many pages it is. It's a thick book. We're looking at 465 page book. It's a fairly big read.
That's a nice book.
And then there's this one, The Fantastic Inventions of Nikola Tesla.
Yeah, that's all his inventions, right? In the
Yeah.
yeah.
And I think I've got a couple more kicking around here somewhere. Hold on, bear with me. I started a small little book collection. Oh yeah, this one's kind of interesting. Homemade Lightning. It's a creative experiments in electricity. They do a lot of electrostatic stuff in this. And it's by R.A. Ford. It's the 3rd edition. That's another good book. I've been going through that. There's some interesting electrostatic stuff. And then the other one I got here is Inventor of the Electrical Age by W. Bernard Carlson. This one here. And then the other one I got is Eric Dollard, Common Language for Electrical Engineering.
I just
Pone
got
Line. It's the Lone Pine Writings. This is the big one. This is the really interesting book.
yeah, that lays out your measurements real well. The Siemens and the watts and everything.
Yeah, he's got a lot of math in this book. So, and the other one I got here is just kind of not really electricity, but it's geoengineering and transhumanism by Elna Freeland. So that's another book that I have. So I've got a little collection here started. And this is a thick book too. This is really good.
That one looks like it bridges the gap between the tech and the stuff like the wackadoo that I talk about.
Yeah,
planner.
like this one is almost 700 pages. 658 pages to that book.
I've never seen that book. That's cool.
Yeah, this one's a thick one. This one's a big read.
Oh my
So yeah,
Engineered
there's some-
transhumanism, huh?
yeah, geoengineered transhumanism, how the environment has been weaponized by chemicals, electromagnetism, nanotechnology, and synthetic biology.
Yep.
Yeah, I'll be picking up a copy of that.
I'm just
Elmer.
gonna go visit him and sit in his backyard reading for a month.
Yeah. Yeah, and this little, it's a small collection. I don't have many books, but there's a lot of reading here.
Yeah.
But this one here, I really like this one. This has a lot of cool electrostatic stuff.
Neat.
Yeah, some old.
Doesn't it
show
feel
you how
good to have
make
a library though? It feels like because you read through it once, whatever. You could always revisit it, but then it's always there as a resource. It's just it feels so much better to have it in physical form. I
Like
feel
this
like
one here is really cool. It tells you how to make a Leyden jar, and it gives you all the plans and everything. It gives you all the instructions how to make it.
Did you know it
Gives
had
you
a
some.
chain in it?
Chain right at the bottom of the Leyden jar. Yes.
And there's a lot of cathedrals that have big chains and sensors hanging from the ceiling. And
Yep. If you look at the right time of the day, you will see an electrostatic discharge coming off the spires on old churches, cathedrals, right? Really interesting stuff. I've seen a couple of video clips of this phenomena. I'm going, whoa, what's going on here?
Go hang around
What?
one just before a lightning storm, and you'll
Yeah.
notice feeling
Yeah.
changes in the air.
Exactly. Yep. But yeah, when I seen that video of it, I'm like, "Ooh, wow, this is interesting." Obviously, they knew about something that we kind of overlooked, or most people did anyway.
Yep, I agree.
Yeah. One
so-
book I picked up recently, and it was at like Victor and Michael's recommendation, was Quick Vidium.
Oh,
That
nice.
book.
do you like?
Absolutely love this thing. After getting into it, like it makes you feel like if you took an IQ test, you could get 100 on it. That's good, right?
Yeah.
Is
I like the way
that
it's
good?
only
I got 100 on my IQ test.
a new
Supposed
page every day.
I think Genius is 134 or something like that, isn't it, in the IQ?
Yeah, it's not super,
IQ,
it's not super.
yeah,
difficult.
I think it's
139.
anything around 139 to 140 is considered you're pretty good.
Yeah,
I'm
right.
For my age, I'm doing okay.
I don't know. I think I did one of those online IQ tests. So, but I don't know how really accurate they are.
I know. Mine said I did the test faster than anyone else has ever done it before. I broke a record. I don't know how true that is. Probably says that to everybody who does it.
Just to make you feel better.
Yeah, exactly, right?
Just to make you feel better. Yeah, we're gonna tell you you're
That's
smart
it. Did
today.
it offer you a personality test afterwards?
Yeah,
For an extra
really.
charge?
I failed on that one. What do you mean?
Yeah. Yeah, I'm a genius, but I'm still a schmuck.
Yeah, schmuck. Yeah, schmuck, man.
Well, that's the old saying. I might be dumb, but I ain't stupid.
There you go.
It's better. Yeah. What is that one? Oh yeah, it's better to be a smartass than a dumbass.
In a nutshell. Oh, look at me! I'm in a nutshell.
Did you read the
Yeah.
private chat there? I asked you a question. You don't have to answer it. You open.
Well, that's for Victor.
What?
You reading the private chat?
No.
Just click over the little icon private chat on the right, and then you'll see the messages there.
Morals and dogmas. What? Just the chapter listing?
Yeah, the chapter listing, and if you want to do the whole thing, I would so appreciate it. I'd even
Oh, dude, that book is like this thick.
yeah.
Oh, man.
What are you guys talking about? Get me in trouble?
No, not at all. Not at all.
We have to refer to that as M&Ds.
How about parts of one chapter? I'll get back to you on the numbers.
Daddy old man.
all I
Daddy
ask.
old man.
I guess it would depend on what I read from it, whether I would want to share it.
That's fair. That's fair. I get that. That's why I want
I
to
don't
copy.
want my life to be, I have a dog I love and family, so.
Yeah, so do I.
Uh,
But I'm not willing. For me, it's different. For me, I don't know how to.
are we still at the level where there's a death penalty for that? I mean, we're not in the dark ages anymore, so
No,
are
there's
we
still
really
death
that
penalty for that.
still.
You know what? It's like this. They say that once you get in, if you try and get out and you speak what you've seen in there, guys will do their thing. Give me a break. Guys can't even get up to go pay bills. They don't want to deal with other people's problems. You know what I mean? Nobody's going to do nothing. They're too freaking lazy. They just want their money and sit back and do what they want.
You know what the deal is with that is if you could figure it out on your own without them, you just made it that you're better than them. Not better than them, but you did it without their assistance, and there's no problem with that whatsoever. If you go through their ranks and they show you the way, and then you give up the way,
My issue is
tends
they
to be a little more problematic.
my issue is they swear an oath to a dead man who's nothing but a scumbag when he was alive, and then they keep everything in secret to their own people until they hit a certain level, and then they tell them something that's the opposite of what their people believed. To me, that's the ultimate scumbaggery. That's why I have nothing. To me, they're like the scum that forms at the side of your mouth on a hot date when you don't get a drink when you're walking through like a that's the kind of thing I think. Okay,
Thanks for the visual. I got it.
yeah, that's
Yeah.
just my opinion. I'm one of those kind of guys, and I'm sorry. But
No, you're not wrong.
if
Lead
it
people down a path.
if it didn't affect the innocent, I probably wouldn't care at all. Go do your thing. I don't care what you're doing amongst your friends, and that's your thing. I get it. We all have lives to live, but when you're affecting the innocent for your own benefit and doing it with a smile, that irritates me beyond a level I just can't explain. There's
Well,
no word for it.
I mean, where it gets funny is that there's only one truth. Okay. And it doesn't matter what truth you travel to get to that truth, or what path you travel to get to that truth. But once you're there, what you do with it, that's what separates you from the rest. At every, and that's sort of it.
I
There's
don't
one
know.
truth at the end of the road.
Yeah, I get what you're saying by that, but the path that you take to get to that truth, I think, matters as well.
It absolutely does. If you do so on the backs of others, then
Yeah,
Mhm.
yeah. I don't. I've always
that goes down to intent, like we were all talking about, and Victor has chimed in on, and everyone's chimed in on. This is a very intent-based thing. You have to have good intentions for this to all pan out properly. It's very, very true.
absolutely.
And that's not woo. It sounds woo, but it's not woo.
No.
All right, guys, let's get back to some free energy.
Free energy. Look, I found out how to bend a pencil while you were gone.
Actually, you know what? My aunt used to bend spoons with her fingertips.
Oh, that's cool.
Oh yeah.
Yeah, I don't know. To this day, I still don't know how she does it. I really
Gotta
don't.
ask Hutchinson.
Yeah.
Bernie,
Wow.
I go bull. Just saying, buddy. Just saying.
Sorry, I can't put up every comment.
Nope, I don't want to put it up. I'm just saying.
Okay.
Where's
the other-
Mr. Bernie these days? I haven't seen him do many live shows lately.
Is it
Oh,
work? I saw him on construction site.
He's been doing them. He did he did a Wednesday thing with I can't remember his name right now. I'm sorry. Yeah, he did some live. It was different though. It wasn't with science.
Oh,
Yeah.
hold on. Was it with that the blonde haired guy?
Yeah, I
forget
can't
his-
remember his name right off the top of my head. Cool.
Oh.
Cool. Good character.
Dude, the guy talks a mile a minute. Like, he told me everything was porn, okay? As he went through the list. And I'm like, oh, man, I feel so bad about my life now, right? Then this next time, okay? Oh, I forgot what he was telling me. It was just, that songs were magical spells, okay? So here I am listening to the songs every morning, and now I'm thinking, oh my God, okay, everything's porn. It's now magical spells. Where the hell is my life going, right?
Yeah, you just want to. You just want to.
I don't know
You
what
just
to
wanted
believe
to.
with this guy.
You just
every
wanted to
time.
hurt yourself after listening to it.
Guess what? That's how you know it's working.
Oh, geez. And he talks so fast.
Yeah,
It
he
was-
does talk quick. Yeah.
It was like, man, if he could read the books that Mike just showed, I'd be so much smarter. Okay. I would turn it on every morning. Boom. A couple hours, get the 500 chapters done. We'd be good. Dude, the guy doesn't breathe. No,
he
he
barely
does not
blinks.
breathe.
We used to call a person like that. We used to call them motor mouths.
Oh,
That's what I got called as a kid.
A
Oh,
motor mouth.
Really, Victor? No offense. I could not picture that. I know you're telling the truth. Don't get me wrong, but you're a quiet guy.
yeah.
Nathan, you got to have them on just for sound bites.
Oh,
Yeah,
Oh, yeah, put him in the transporter.
there you go.
I'm sorry, man. No, I just get tripped out first thing in the morning. It's 1 a.m. and I'm watching this, and I'm like, should I be awake right now watching this? I don't feel right. I think I need to go back to bed, but then with the topic, I can't because then I'll start thinking songs in my head, and I'll start thinking that they're porn or something, and then I'll start thinking I'm putting magical spells on porn stars, and I'm like, oh my god, dude, I can't do this.
You just went back to
Gotta
Mushroom
stay awake.
Planet.
Yeah, so I
Got back into the
decided-
jar.
yeah, another cup of coffee might just work out.
That's awesome.
Oh,
Thanks, you hurt my cheeks from smiling.
Right? That's great, though. That's the kind of pain everybody should have.
oh man.
Your recall on that was probably better than it even was live. To be real.
Maybe it just gets twisted up in there sometimes. I don't know. But he was going through food and everything else, and like, oh, that's an addiction. That's porn. And it's like, okay, what about reading a book? Oh, well, that's an addiction. That's porn. And I'm like, oh my God, dude, everything is. Like, is that the way you think about it? Because I didn't. I had no thoughts of that whatsoever when I read a book. I thought of sleep.
Yeah, I fall asleep sometimes.
Yeah, all the time.
If it was porn, I'd be up.
Yeah.
Jeez.
We know you, Joe, because you can't draw a circuit without it.
Oh, I have a coil to show. Sorry to. I have
ahead.
a coil to show. Hold on a
Oh,
second.
yeah, go for it.
Just let me switch my camera here again. I don't think I've shown this one to you guys yet.
Oh,
This was actually given to me from a guy that works for. Oh, I switched it back. Okay, hold on a sec here. I'm doing this all off a cell phone right now.
We can tell we see your finger come into the screen.
Yeah,
Yeah.
this coil here. I got a big hand. Look how big this coil is.
Nice.
Oh, it's a donut.
That's a
Yeah,
6
the tool, right?
Oh, very
This
nice.
thing weighs about 30
wow.
pounds.
Oh, cool.
Oh, yeah.
30 pounds. Look, it's on the bed here. Look how it just squishes into the bed.
You
The
can
thing
see
weighs like
Something
30
like that out
pounds.
of a microwave.
Oh, this thing's bigger than that.
Yeah.
It's huge.
that looks like out of a radar dish system.
It's huge. Look at the size of it to my hand.
Yeah, that's bigger than
And I
the
got
one
big
on-
hands. Yeah,
it's
this
bigger
thing's a
than the one I
monster.
got.
What's the
So
resistance?
I actually hooked this thing up to my Don Smith generator, and I was able to get quite a bit. Well, it's got four channels on it. I was able to label. This one's a low input. This one's a high input. So I got him kind of categorized. He didn't actually know what the winding combinations were on this, so I kind of had to figure it out on my own. So I kind of labeled everything so I know which one would give the highest output and which one would give the lowest output, and what channel was the actual input for the coil. So if you put your input on these two, for example, you can get 3 different levels of power off these.
nice.
Yeah, so it's like a 3-phase toroidal. Now, know what's a really cool thing I've done with this? I could take a plasma ball and stick the plasma ball right on top of it, and I get power all through all the wires. And I can
Nice.
light up light bulbs.
That's
Is
cool.
there like an aluminum foil or wrap around it of some sort?
No, it's just a regular, looks like a plastic wrap, really.
Wow. I wonder
Yeah.
if that plastic wrap has something to do with being able to collect that static that comes off of the plasma globe.
Yeah, I don't know. Maybe it could be an insulated plastic. It's pretty heavy duty plastic on it.
You know,
But
when
you
I was
could-
looking at it originally, it looked like it had I mean, it probably doesn't, but it looked like it had some fibers running through it, like it has that kind of
No, these are, I believe, the gauge wire on this one, from what I could see on the outside, anyways, is looks like 20 gauge or even 18 gauge wire. But it's, you know, your regular magnetic wire, and then it's got a steel toroidal core. Not sure if it's steel or if it's ferrite or whatever it is, but it's heavy as all hell, though.
Be careful when putting plasma bulbs near them. I used to play with them, putting magnets and stuff on the plasma bulb, and I found out you could put a magnet on there, and if you go and touch it, the spark jumps.
Oh,
You'll
yeah.
actually burn your cells and
Yeah,
burn them
yeah, you
black.
get RF burn. Yep, I've done it. Actually, I've lit pieces of paper on fire with the
that foil?
discharge. No, with a plasma ball, I've done it.
Aluminum
It is-
foil does the same thing.
Yeah, exactly. That's how I did it. I put it beside the aluminum foil and had a piece of paper there, and actually had made an arc big enough. It actually started a little, flame.
Yeah, no doubt.
But- Yeah, one of many coils I do have. This is by far the heaviest one I've got.
no
yeah, it's
kidding.
good.
It looks like a monster.
It is. You drop this on your foot, you say goodbye to your foot.
got some girth on it. You know?
Oh yeah. Well, just an example, the inside of the toroid, that's about 3-inch diameter, 3.5-inch diameter.
Was I right to say it's about 6 inches in diameter altogether?
Yeah, maybe a touch bigger.
Nice.
Yeah, no, very cool.
Yeah,
Yep.
good.
Rig
It's
that
neat to
puppy up.
experiment. Need to experiment with.
I'd like to set it under my rotary spark gap.
Yep. Oh, I've done it with the spark gap. I put 11 kilovolts through this thing.
It's an awfully big hole, Mike.
Don't go there.
It's Canadian. There's 3 holes.
All right, so you're gonna hook it up, and then we're gonna
Oh,
throw hot dogs through it like a carnival dude.
Fucking Mike.
Oh my god, I'm choking here.
This is what happens when you have me on. Don't we already know this?
Yeah.
At least Gerald ain't drawing the circuit for it.
Yeah.
Horrible. It's horrible.
Oops.
No, you gotta have fun with it.
Oh,
I'm going to try that thing the guy in the chat said. I've got a copper, reels of copper tape, 2 pounds of bismuth, and I'm going to try that layering heat.
Nice.
oh yeah.
Answer to this question: yes, I already have, and I can't contain the energy. Like at all. I don't know what to do with it. It's too much.
I have that problem too.
Yeah, it's like thousands. I don't know. I think I was getting some like 1,800 volts on one side and 1,200 volts on the other side before the meter went pop. And I was like, okay, I'm not even going to play with that because I can't control it. It all has to do with like when you take your plasma globe and you put your tin foil or your aluminum foil around it, that's acting as like a high voltage step down transformer, and my coil is like a step up transformer. So if I had used maybe 3 lines and at a high gauge, I might have been able to control what was coming out and actually do something with it, but not with my coil. It was bad. Blew a meter for that one. So yeah, be careful with plasma balls because you can pull energy out of them. They're just plasma oscillators. That's all they are.
That's my Oregon accumulator.
Cool.
Mm.
The one with the rod sticking out?
Yeah, that's my Oregon accumulator.
Have you done tests with it?
Yeah, I've done a little bit of tests. I want to do more. I just haven't really had the time to do it. I tried to do some charged water and stuff like that. I've yet to like put plants or stuff in it.
That's the real
Yeah.
test.
Is an orgone accumulator just a metal box with natural like
Yeah.
fur and fibers outside it? Or
Yeah,
what?
you could use steel wool. Some people like using particle board. Yeah, it's just a mix between organic and wood and
Or fiberboard.
sheep's wool, fiber board,
Yeah.
stuff like that. But the interior is a steel plate. So basically, it's a capacitor without the outside plate.
Finally, someone who figured it out. Yeah, it's a capacitor that contains that orgone energy, which is
Yeah.
essentially the cold dielectric capacitance between two
What
plates.
what Eric Dollar calls it is an electrostatic condenser.
Static. So.
Yeah. That
Good way to
sounds-
Oh,
put it. Yeah.
And Eric Dollar actually did experiments with it, and he said he put it beside a pot of plants, flowers, and that. Said within 20 minutes, the plants turned away from the sun and pointed towards his box,
Crazy.
Yeah.
and
Yeah.
that made him a believer. Right after that, he said that made me a believer.
You know, the wool, because that's come up a couple of times, you know, and with Tesla and some of his work too, he was always drawn to wool. I always wondered if the wool component of the work had anything to do with the chemical composition of lanolin, because lanolin is a very, very interesting substance, you know.
Yeah.
generally.
I heard the best results are with sheep's wool.
Yeah.
So,
Yeah, that's flannel.
Yeah. When I used to restore old straight razors and stuff like that, I got into leather work around that same time. And I had actually bought a really, really old razor strop. When I say really old, I'm talking like 120-year-old piece of leather.
wow.
You know, so think about what a 120-year-old piece of leather is
Yeah.
like.
Yeah.
You know, I took my time with it and used lanolin on that leather, and it brought it back like the day it was made.
Really?
You know, over time.
Yeah, because usually
because of the
leather,
collagens.
right? Usually the leather at that age is, it gets dehydrated and it cracks,
Mhm.
it breaks down.
So
it
I was
starts,
fearful. Yeah, I was fearful when I was working on this that it was going to crumble on me. And
right?
I coated this thing in lanolin. I let it go. Then I waited like a few weeks, wiped it off, reapplied it, started working it, stretching it, working it in. It took a little while, but I was able to restore a piece of leather with the lanolin back to what it looked like when it was brand new, with the same surface shell and everything, without cracking the surface shell of the leather, which is
Wow, that's-
mind blowing. Now, the
yeah,
reason
that's
that I'm
pretty
saying that this
incredible.
might be relevant and interesting, okay, is this. It's a collagen situation with it. Okay.
Right.
What I recently found out is that bioapatite that makes up
The cartilage in your joints.
no, your actual bones.
Oh, your
I was
actual
trying to stay away from anything to do with, but I think that's
Yeah.
okay. I think, so bioapatite is bone, right? It's mildly piezoelectric, especially in its in its growth stages. Okay. And it would create pox inside of the bioapatite, and in these pox would store some electrical charge inside of the osseous structure of the bioapatite, which would then attract collagen, growth to those specific points. Do you see where I'm going now? So you have collagen being attracted to these electrical points as points of growth, lanolin bridging the gap between degraded matter and material, bringing it back to a new form through collagen, and that's the connection.
So hold
You
on,
know-
this, we're just talking about a piece of leather, right?
Yeah.
And we were talking about putting some, I would imagine, oils on it to bring it back to life.
Lanolin.
Okay, it sounded like something else, so I just want to make sure. Okay, we're good.
Well, yeah, but
But
I
on
mean,
that
the
other
relationship there was that it's the lanolin's a collagen.
I just
Dave.
wanted to stay away from any medical. Okay,
I
That's
thought
a rumble.
I was, yeah.
that's That's why I
Yeah.
wanted to clarify. Make sure it wasn't anything else.
No,
Yeah.
no. If anything, I was maybe talking about like biomechanic slightly.
No,
but
no,
it's
he's
not
using it.
health,
He's
but
using it in a different context.
Yeah.
Okay. I just
Yeah,
want to
so-
make sure.
But,
No, it's not. It's not medical advice. It's he's telling the relationships between biomatter and what he was doing with the leather to restore it. Right.
Yeah,
From-
and how that tied in with the wool usage in your orgonite cell, but also the wool usage of Tesla previously, with lanolin being the connecting factor between the wool, the orgonite,
Yep.
you know, and then the leather restoration, and then on top of that, the bioapatite attraction of collagen growth
Right.
and exposing its potential like electrical properties.
Okay.
Yep. Oh yeah,
Yep.
no doubt.
We
Just
could get
sensors pick up certain things. You know what I mean? So I just want to make sure.
No,
I can.
yeah.
Crystal clear as day.
deep into that chemistry on a rumble that we gotta do.
Yeah. Yeah. I mean, that's a tale for another day, but it's not even on that. It's just fascinating to think the possible application of, you know, having
Wool being the
the lanolin of the wool being you know, a possible element that
I
of
wonder
use.
if you can make a coil out of sheep's wool.
Well, it's because it's an amazing dielectric and electrostatic. It's like a magnet for electrostatics.
Hmm.
If you're
that's,
like even
that's what they-
even like silk.
Thank you.
Like-
You see where I was going with this, Mike. I appreciate it.
Yeah.
I was a little convoluted with it, but yeah.
Yeah, like you get a good piece of silk and you rub that on a PVC pipe, and the electrostatic charge is actually really amazing. I was shocked how good electrostatic charge you can get from even amber too. I heard amber works well.
Wouldn't
And
wool
silk.
have to be coated for it to be some form of like an electrical wire?
But the wool is coated with lanolin. That's the lanolin's the
Yeah.
natural sheep oil that is in wool. Well, they extract the lanolin through in yarn. So
They
if you were to
do?
add lanolin back to that,
Okay. It's already a coil
Mhm.
in a sense. So I would need it couldn't be like a roll of wool. It actually has to be like basically from the sheep, right? Like
Well, say you
they
say you
sell it.
had that next to like say a plasma ball, Gerald.
ooh, that's an interesting
See what
idea.
would happen with that, and a piece of aluminum foil on the other side. So, say attach a piece of the yarn directly to the Tesla ball,
Yeah.
and then attach the other end of the wool to a coil, and see if you got charge. It might actually be able to send charge carriers through the wool right into your coil.
That's interesting. I'm going to try that because this is actually a geometrical coil. It was
Yeah.
wound for me just the other day, and the center ground comes right out of the center's open core. It's not much
Yeah.
of an open core, and then the other one's from the starting point. So that's an interesting thought. I want to try that.
next week on Straight Dope, we're all going to be crocheting.
Yeah, really. I'll be making large socks and yeah.
I love it.
We cracked the code.
Nathan's
It's the
shaking
old
his
We're gonna have a couple grandmas on here showing us what to do.
Well, see, now think about that though. If this big if, okay, we get into a little bit of woo here. Connection being, this is a pattern from like hundreds of years ago, right? It's a known pattern. So what if it was passed on through generations by the women doing yarn work? And
Yeah, they already beat us to that. Have you ever seen the carbon fibers with all the copper line
Yeah.
run through it
Yep.
and
yeah.
woven directly into the pattern?
yeah, that's actually hemp, is it not? Don't they use hemp for that?
They use carbon too, but I mean, let me tell you, I already had the thought so long ago in the material science end of things. I'm like, The future is in fabrics, really, but that was before 3D printing really took on the
Yeah.
level of intricacy that it did. But I was like, you could sit there and weave anything you want into any fabric pattern and whatnot, and it'll have all sorts of different properties. And then you could
Yeah,
you could
you're-
seal it with resin, for crying out loud, and then it's a structural component.
Yeah, because you're creating not a nanostructure, but you're creating a geometrical structure, but using yarn, right?
That's it. And that's how you
Right.
create the dimensionality of the 2D path that I always said about the coils being 2D. If you start building layer and layer and layer of it in a compound, now it's no longer two-dimensional. Now you can have multiple fields working in small areas.
Yeah.
I'm a knucklehead that don't listen to me. This is not advice.
Hey, no, but it's those things that trigger the memories or thoughts that will take us to the next stage, right? That's where
That's it.
we're at. That's why mine, us hashing it out or sitting there and, throwing the spitball around, so to speak, it means more than you think, because we're all throwing around our ideas and something's going to stick, whether it be me, Ethan.
Hey, here's an idea. Get a Tesla plasma ball, somehow find a wool patterned blanket, put it over the plasma ball, and then put some tinfoil on top of that and see what happens.
I actually have that very blanket that you're talking about right now. There's a blanket upstairs that's been crocheted into a basically a Merkaba, right? It's the 6-pointed star.
Right.
Yeah.
I have a feeling if you were to do that, put the blanket over the plasma ball and put a piece of tinfoil on top of the wool, that the electrostatics would go through the wool and supercharge that tinfoil. It might actually make the tinfoil lift off.
Well, that's
Yeah,
interesting.
I'm running this in my head right now, and I just see that whole entire thing acting as a big static sponge.
Yeah.
Is what I see. I see like a real heavy density of static on the surface that diffuse off. And the more,
That's I wonder if I can implement that.
I don't think
I know. I'll test with it. I just wrote down the experiment. I'll let you know what happens.
yeah. You could find someone who's weak-handled and make them a Jimmy hat and try it out too and see if they're fixed.
I think he's already got one.
What do you mean?
Did your wife make that for you
Yeah.
for the cold winters?
No, actually, you know what it is?
Sorry, Gerald, that sucks.
No, it's the beginning of a slipper, right? For my daughter, because she's got small
Oh,
feet.
okay.
It starts like a cup, and then it goes into a tube, and then she makes the corner part, right? So I was looking at it and I was like, that's the perfect coil. I better stop it now. But hey, it's just the tip. Right?
Oh,
What did I do, Nathan? I'm sorry,
See?
man.
it's a tip warmer.
I love it.
Hey, Mike,
It's for-
I got a question
it's for your
about
cold
that.
winter.
Swallow, right? I mean, I'm just saying. Anyway.
Yeah. No, I think there's something there though. Like, I mean, it's a little wacky, but it's the connections are there.
It was just a thought, you know what I mean? Popped into my head kind of deal. I'll try it. Never know.
Hey, Mike.
Yep.
Does the orgone, since it's electrostatic, does it discharge when you hook it up, or can you make the static actually flow?
You can, the orgone flows. They say if you have, say, a line of electrostatics, the orgone accumulates around the static charge. That's what Wilhelm Reich was explaining in one of his
So
books.
they don't just discharge.
No, they actually kind of like hover around the electrostatic charge. Now, if I guess if the electrostatics got discharged, I guess the orgone would probably eventually dissipate, right? But as far as from what I understand, if you have something that's electrostatically charged, orgone is present.
What if you put it inside of a cone like this?
You can.
What if you put it
in
inside of a cone and just try to, like have it so the energy has like a want to consolidate?
Right, because like Eric Dollard says, it's fluidic. It flows like a gas.
Interesting. 'Cause usually
Where does it tend to accumulate? I know you kind of just said it, but where does it, like in that cell, so to speak, where does it accumulate?
Inside the steel box.
Inside the steel box.
Right.
Accumulates
So
like a gas.
Yeah, and he says it does work. He's actually, Eric Dollard says he built one, and he says they do work.
Well, I'm
Is
gonna
that
try
static inside the box interacting with the atmosphere in the box in any way with any
Right,
byproduct?
so-
Like, are you getting O3 or anything?
Well, what he's saying, basically, it's an electrostatic condenser. So it has to be operating in an area where there's very little area where there's like very little like say like cell phone towers, AC, parasitic electricity in the air. You got to go basically in the middle of a farm field. What is what he's saying, right?
Yeah.
Where there's very little interference, and then it will accumulate. It's an accumulator. So picture a capacitor with the outside plate missing. That's what an orgone accumulator is.
So it's going to be sensitive to its environment then, right?
Very much so, yes.
A feedback
Yep.
mechanism. I like that.
So
I mean, I have to put my head around that one a little bit more. What's going through my head immediately is how can you have it accumulate in higher degrees of interference areas and actually pick up on those interference, like actually accumulate the interference as opposed to just, the free
question.
charge. I don't know.
yeah, definitely. I've read quite a bit on his stuff, even like the Cloudbuster, and he also made an electric motor that ran off of an accumulator, and he talked this thing called the Y factor. And for months and months, I'm researching what is this Y factor, and I finally found out what it was. We're not getting into medical stuff, but he says the second you introduce your body to the circuit, you get the energy.
Okay.
I'll leave it at that. That's the Y factor. When you attach yourself physically to the device.
Oh, so that's the reason for all the bioelectronics that's going on right now.
Exactly.
Yeah, I just put a link to one from Physics World, one of the latest. They're putting silk on graphene.
Yep.
Wow. Mimicking nature, are they?
Now I'd like to see that on spider silk,
Yep. Well,
So-
who's not to say that spider silk attracts orgone energy? It's around us. It's in the clouds. It's everywhere. Orgone is like it's fluidic. It's like a gas. But when you have electrostatic potential in its area, orgone likes to attach itself to it.
I read somewhere
Fascinating stuff.
that silk hanging in the wind, especially in the deserts, that when the wind blows the silk back and forth like drapes, it's supposed to create static
Yes.
in Yurka or whatever the tent is that they Yeah.
Yep. And create a lighting. Yep.
It's also a mechanism as to why spider silk captures small, tiny insects that don't get stuck to other things as well, but they could crawl freely over it.
So, like, if you want to do an experiment, you have to be in an extremely dry environment, because as second you get any kind of humidity or whatever, it will kill your experiment, especially dealing with orgone. Now, apparently, you can see orgone energy around a person. There's it's a blue glass. They used to use them in making lights for the street.
Yeah, I know the blue glass you're talking about. They outlawed that the stuff that makes it blue.
Oh, the cobalt.
Yeah, exactly. Cobalt blue. Yes, I have a piece
Cobalt
of it.
blue, yeah.
I have it. Well, apparently, if you use and look through that, you can see the orgone accumulate around objects.
Apparently, if you look through cobalt blue, you can also see UFOs. That was one of the reasons, at least one of the conspiratorial reasons why they got rid of cobalt blue, because somebody figured it out and made a pair of glasses with it, and they were searching the skies and literally finding hundreds of them. And all of a sudden, cobalt blue becomes, hard to get.
Yeah, and I was able to get it through my buddy that finds all this stuff. He was the one that found all those spark gaps for me and everything.
Yeah.
Well, he was the one who actually found me the cobalt glass.
What were you gonna say, Victor? You got excited about cobalt for a second. I'm sorry, Mike.
Yeah, I could see the excitement on Victor's face.
Well, I remember watching a Clint Eastwood movie. I believe it was The Outlaw Josie Wales. And he catches this old Indian. And anyway, the Indian was talking and he's going, yeah, well, all I have is this little red piece of sugar candy. He goes, but it's not for eating. It's only for looking through.
Oh.
So check this out. You see this necklace that I'm wearing right now? Right? So this is a stone that I found, right? They call them hagstones. It's by me at least, they're very hard to find. All right. But what makes it a hagstone, okay, is it's got to be a piece of quartz. Okay. It's got to be found in water. And it's got to have a natural hole that's covered on all sides. All right. The water has to make the hole through the quartz in exactly that fashion. Right. So if you could see that.
Oh, yeah. Okay.
Right. So supposedly how they used to use them, right, is if you look, you would peer through the hole, and look, that it's woo stuff, but it becomes interesting because when you start talking about it's got to be quartz, it's got to have a natural hole that was created by water, and you're peering through it, and all the interactions between quartz, pressure, water flow, and all these things. And now you have a hole made in the middle and you're peering through the thing, like it becomes an interesting topic of conversation.
I get that.
Yeah.
Absolutely. We got to stop talking about holes, though.
Yeah. That's fair.
I'm just kidding. But you're not wrong, though. Like,
hey,
yeah, I try to take it away from the orgonite. I apologize because I have lots to say about it, but it all rides that's such a hard line to ride.
Yeah.
With the orgonite.
Other event video we need to do. What were you saying?
We could have a show based around Year of the Hole.
3 holes.
Year of the 3-holer.
And the big hole, it goes in the big hole. In the middle. No. Wait.
At least he was talking about 3-holers and not 2-holers, because that's a whole other channel.
That's a whole other topic.
Wrong. Victor's just shaking his head going, what have I done?
It's 2024. However many plugs you need, do what you may.
I ain't touching that one with a 10-foot pole.
Listen, I just came back from Salem, Massachusetts, and I was like, "Oh my lord, there ain't only witches here, that's for sure." Oh, there's a lot of inappropriate jokes I can make on backstage. We'll do that later.
Yeah,
Oh,
I could get us all into trouble real quick. We don't want to do that.
Nope.
oh yeah.
Peace, love,
Yeah,
good stuff.
absolutely. But jokes, man, jokes. That was what the world used to be. Society was built on. Now, people can't take a joke. They can take it off, but they really can't take it right. You know, you gotta laugh at yourself. Life is short.
Oh, yeah.
I want some cobalt blue. I want to test that theory where apparently you can see, UFOs through these glasses.
So hold on. It's just cobalt blue glasses? Is that what we're talking about?
Well, it's cobalt blue glass, right? So you turn them into glasses, and if it shows argon, like Mike's saying, it might actually show the glow around the coil, because remember, we don't see that plasma between the wires, but it's there.
Yeah.
So
Yeah, it's a different light spectrum.
That will show it, yeah.
Yeah.
So hold on. So they have vodka that's sky blue and it's in a blue bottle. Is that the same thing or something different?
No,
No.
different.
No.
I
Different?
thought so
Okay.
too.
Cobalt blue.
Yeah, and it's got to be real cobalt glass. Like it's that's the thing is like it just can't be cobalt blue glass, because then it's just the color of it. It's got to have the chemical in it, the metal in it.
You got to look for wine glasses that are blue from like
Old ones.
Yeah.
Like the 20s, they made a lot of it.
Yeah.
It was popular then.
Did you guys ever hear the story of, I think it was Vietnam? We first developed infrared goggles for the soldiers, and they'd be flying in the choppers.
Yeah.
Apparently, there's stories of the guys seeing flying creatures that look like gargoyles off of temples. And some people are saying, well, that's the Jinn. And apparently the infrared goggles allowed them to see them flying around.
Yep.
And if you saw them and they saw you seeing them, then I guess shit happens.
Yeah, I think the original night vision, if I'm not mistaken, was green. And then eventually the technology changed and they went to the blue spectrum.
Yeah,
well, they used to show it in red on the displays. It used to be red.
Right.
Yeah.
Right.
But it was being filtered through green. So anything in that spectrum
was the opposite.
Yeah. It's a flip flop. But what you see is the red.
Yeah.
Oh, it's a flip flop like iron in your blood and chlorophyll in plants, red and green.
Oh, right.
It's a flip flop, like the flip flop I was talking about last week when I was talking about the photo negative nature of your vision.
Right. Everything we see is actually an upside down reflection.
Yeah, and opposite in color, and the only thing that you see truly is something's luminous value, dark and light.
So does that mean cobalt blue, like you would see red through the? I don't know. I'm not.
No, it's the opposite spectrum. I think. I forget the light color chart.
Yeah.
And reflections mean that the object is not absorbing that color, so it's not blue. It's everything but blue.
Oh, right.
Everything but blue.
Yeah. Just mentally trying to picture that, right? So I got it now. Thank you. Anybody got any? I need some cobalt.
Well, I have a 4-inch diameter lens of cobalt blue.
Ooh, nice. You should be looking. You should have that thing stuck to a digital 4K camera, and it should be doing slow 360s at the top of your house, just for a week. See, never know, man.
Or even just stationary, just see what's what, and run a couple tests around it too, and see what's what.
Just if that rumor was real or not, right?
Yeah,
definitely works as a photo filter, no doubt.
Yeah, absolutely. What's the the welding glasses that have that green glass? What's that made out of? Does anybody know?
I don't know. I just call that a
Not
welding
too
shield.
sure. Yeah, it's just a heavy duty filter. You could actually look at the Eclipse with those. They're
Yeah.
strong.
Nobody.
Yeah, you don't want to be looking at a welding arc. That's for damn sure. I'll tell you that firsthand.
No, I got welder's
Yep.
flash before.
Yeah,
Yep.
That's
I
not
caught
fun.
the reflection off of glass across my alley from my blue laser, and I almost burned a hole in my retina. My
Oh,
hurt
man.
so weak, man. It's insane. Gotta be careful with this
I gotta
stuff.
plug my phone and I'll be right back.
Yeah, and you're when that happens, you get the welder's flash. Your eyes just start tearing like crazy.
That's exactly what happened. Started
Yeah.
tearing and I couldn't stop, and it burned. Oh, it sucked.
Oh yeah, bad. I just want to say hi to Merkaba.
Hey, Merkaba!
Just hanging out in the chat.
Nice. We have an awesome chat. Lots of intelligent people in there. Blows
Absolutely.
my mind. The conversations that go on. The suggestions too. It's just like,
Well, some of them are
Yeah,
different than the conversations going on with us, so I'm trying to figure it out. sometimes.
it's hard to keep up in the comment section and then discussing
Yeah.
what we're discussing and mentally handling both at the same time.
That's what I was trying to do last night with our show because the chat was on fire last night.
Yeah.
Well, thankfully, my wife has ADD, so when I listen to her, I hear 5 conversations at once, and it's coming from the same person.
Yeah.
So I'm kind of used to it. You know what I mean?
There you go. I love it. This has been brought up by us before. Aaron's breastplate from the priests. It has multiple different types of crystals or whatever you want to call it. There's diamond in there, topaz, there's corundum that we talked about. So I kind of wonder, like, could those be things they're supposed to see through? But they're no, it's a chest plate. So it'd be more like a frequency pattern, I think, than anything. But we did discuss it before.
You guys are gonna think I'm so stupid, yo. I am so stupid. That's fine.
Nah.
Oh no, I didn't tell you what I did.
Stupid means you can't learn. We can all be dumb, but you can't all.
I unplugged an extension cord from my wall to grab it for my phone charger, but that extension cord was running another extension cord that I then tried to plug it into to charge my phone. I didn't realize.
Okay, yeah.
Guess what, free energy people? That didn't work.
You need to wrap it. You need to.
I just ran an experiment for everybody here.
That's great.
Oh.
You saw it live before you even knew it happened when my light went off. Oh my god.
Oh, it's funny.
You're unplugging it good. Why isn't my light working?
At
Yeah.
least now you know where to hit it with the hammer.
Amen. Isn't that the truth?
Oh man.
There's a question here. No, I didn't see your question prior to that. Ooh, ebook version. I love that.
Yeah, I need some of those.
Yeah, please drop it in the link.
Yeah, because
the class. I'm just kidding.
working on stuff, man, it's so much easier with some kind of ebook in the back or something. You know what I mean? Just talking.
Yeah.
So
I do that with some of our videos. I'll play them in the background. I've already watched them like or a live that we've been on, right? And I'll play it in the background to pick up what you guys have said prior that I've either missed or just going over it, going, oh man, that was dumb. Why did I say that? Or, stuff like that. So, yeah, while I'm doing experiments, that way multitasking, you need to do that these days.
Yeah, that'd be better than doing that. What was it? Magic music porn?
Oh man, there was this song put out maybe 10 years ago on YouTube. I have it on my hard drive, but it was taken off YouTube. And it talks about, like, it's a song of all the characters from Worlds of Warcraft and other different video games talking about what makes the internet go. And it was porn. And they sing about it. And it's hilarious, man. I gotta find it. See if I can play it on my channel. I don't know if it'll get taken down or not, but
Oh, I'm sure it will.
I'm sure.
Yeah, it won't last too long.
It's okay. I haven't got a strike yet. Only got one warning, and I took that video down because I had no business putting it up to begin with. So I'm still good. Can afford one strike.
Yeah, you'll see your subscribership go backwards in real time.
I already have. I do all the time. I watch my views go down. I've got video on it. Literally.
Yeah, I keep on saying I'm going to start up my own channel, do my little thing and this and that. And then I'm sitting there saying to myself, man, with what I want to do with this, how long am I actually going to be able to sustain that and be on for before they pull the plug on me? Because, like, if I'm doing it, I'm not holding back.
Ultimately, if they want us off, like if they don't want people to hear us, they're just going to unplug us. It's not that hard to disconnect us at any time. You know what I mean? Like, they don't give a shit. We're nobodies. We're nothing. Even if we had millions maybe 1 million subscribers, they might be a little bit more inclined to look into our work. But I think right now it's just like, oh yeah, it's just a fringe, right? Oh, speaking of which, the Fringe think tank, that's an awesome name, right? So the fringe means to be on the outside of the regular accepted group of thinking, right? Meaning outside of academia, correct? Well, that being said, Jeremy thinks he's the fringe.
No,
So
not even close.
he actually stated it in the last video with
No.
Forbes and stuff,
Yeah.
saying, well, we're the fringe science community that's going to put this together.
No.
So I wanted to bring that up because you came up with the fringe think tank, did you not?
It was Ben.
It was Ben.
Yeah.
Okay.
Yeah, dude, Jeremy's so far from it. As soon as he has Jack on, he just like, here's my hand, here's who I am. You know what I mean?
Yeah, well,
and then he's gonna have him on again and agree with them again. And I'm sorry, that's not fringe. That's I don't even want to care to explain what that is.
No, I understand. Say no more, say no more.
Hey, listen, all things being created equal, it doesn't matter where in or out of the box you are. If you're getting the stuff done, that's what matters. Now, I don't think the stuff inside the box is getting it done. So fringe it is. You know what I mean? But there's tie outs to the inside of the box that make all this stuff work too. You know? The stuff's got to come somewhere. And Jeremy, he talks, he knows what he's talking about.
His only
Out of his
downfall
mouth.
is his hang up on paperwork. You know what I mean? On PhD.
Yeah.
If he looked outside that with the amount of intelligence he has and the work he's done, things could get pulled together. I think it's going to take the inside of the box, the outside of the box, and the box itself to actually get everybody up in the air to a point where we're all, living free. Do you want to say something, Victor?
Is Jeremy
Alien scientist?
Ocean?
Yes,
No, that's Jeremiah.
that's Jeremiah.
Okay.
Jeremiah. Yeah.
I just
Jeremiah
I thought we were
I'm sure
talking about
he's
him, and I
emailed
was going, no, that guy's.
No, that guy's good.
Exotic Propulsion's Jeremiah Pop, and Alien Scientist is Jeremy Reese. Jeremy Reese is a PhD.
Okay. Now I
Jeremiah
know
Pop
who we're.
is,
I'm on.
yeah, he's an electrical engineer, or yeah,
Oh, he's not.
something
Is
like
he?
that.
There's
I
no
don't
way. He's
Yeah.
got to be a theoretical physicist or something.
Well, no, according to him, he's worked for multiple companies, including Elon Musk, and he used to do massive sound systems and all kinds of stuff. So,
Really?
Does
yeah.
he?
Didn't
I
know
don't-
that.
according to him,
I never heard that, but yeah.
yeah, according to him, he worked for Elon Musk when it came to something to do with the motors, the motor that his first generation motor that he had in his car, and yeah, he's worked with a few big companies.
Tell
Apparently,
you what, those first gen motors, those things they put out, man. That was when the gold was different.
it's basically a DC and an AC motor married together in one case. That's all
Yeah.
it is.
Those first
It's
Teslas
smart.
were insane. They really
Yeah.
were.
Yeah, I just don't like when he says, "Hey, I'm on the fringe, but by the way, if you don't have science credentials,
Yeah, that's not fringe. Sorry,
it's not fringe at all."
no.
No.
And then he says, "Oh, but I'm bringing the people on the outside from the garage, and I'm combining them with the people from physics. And then, by the way, if you don't have papers, you're schmuck."
Yeah,
Well,
I
I
don't
don't-
care if you have papers. If you're a decent guy, you're a decent guy, and I don't care if you don't have papers. If you bring
Well-
something to the table, let's hash it out and get it all working together.
Okay, hold on. When is the last time that he brought a garage inventor onto his show to give him the actual time of day to present their theory?
Never
Tell me.
tried
So
multiple times.
where's the fringe?
Yeah. I don't know.
It's like, so, thinking that you're going to take people, first of all, from the fringe and then intermingle it with the academic and in the current environment in which it is. That's like celebrity deathmatch claymation is what that is. Like, it's for entertainment purposes only.
Yeah,
You
that's
know.
true.
Because at the end of the day, you can't expect to have a fruitful and productive conversation when, you have one side and then your moderator would be saying, no, well, I mean, this is the science, this is what I'm sticking with. Here's the professionals. Now argue it out with them and let me side with them because,
Well, we
that's
all
counterproductive stuff.
learn different ways, right?
Yeah. This
Like-
guy says it's not his fault, really. Well, hold on. Let's just understand this. He's the owner of the show. He puts on whoever he thinks. Okay. All he has to do is invite one on. Okay. That's all it comes to. Hey, would you like to come on? Would you like to present? You could show me ahead of time if that's the requirement. Okay. Let me see that you have something. Everybody's okay with that. Okay.
Yep.
The not having him on part and then saying that you're part of the fringe. That's the part we all argue with. Okay. It's not that he's not doing good work in the area that he's in, but be accountable for who you are. And this is what you are, and this is what you put on, which is fine, and people like your program. Okay. But don't say you're something you're not. I don't claim to be a scientist. Okay. So I don't speak like one.
That's why I asked you guys. I think I'm a scientist. Am I a scientist? Well, I do science, but am I a scientist? I don't get paid for it. I don't have a degree. I'm not looking to write a peer-reviewed paper. So technically, I am doing peer review with you guys. Right? I mean, I don't know. Is that not?
I think in context,
Yeah,
this group and the audience would be the peer.
yeah, because you guys are working on the same thing I am. You understand, you've seen anomalies, you've worked with anomalies. We're getting together trying to hash it out, get the stuff into each of your hands, and do the tests. I think that's peer review. Isn't that the definition of peer review? Unless that just equates to only academia and academia alone. Although I didn't see the patent on that.
Well, I mean, to be honest, how do you overcome this? Unfortunately, society wants you to buy credential to a certain degree. You could also buy and fabricate credential. How do you do that? Well, you start a not-for-profit, you group everybody up under an NDA, say that you could talk about XYZ, it's fine. Then you allocate different titles to everybody, and then by virtue of that allocation of that title, now all of a sudden you have a credential. So, Gerald, you are the the founder and chief engineer, project director, and Nathan is the the engineering and theoretical coordinator,
And
the
CEO.
president of that, right? And
Yeah.
and I'm a theoretical physicist all of a sudden, because you guys gave me that title for the not-for-profit, and Mr. Sears over there is the head of mathematics and theoretics, and Mr. Faraday down there, he's stored energy engineer,
There you go.
and
We
the
have
head
a
of that
corporation.
department. And then next thing we all get together under our NDA and we discuss what we're going to include in our papers. And if we have a point of disagreement, then you say, the general consensus is this, but that one outlier or two outliers, they add in that maybe it would be their theory, and now all of a sudden you have a piece of paper with a bunch of names and the names with titles, and you gave it all to yourself,
Yeah.
but it's something, and it's not nothing, because guess what? If you got sued, they'd be suing you as the lead engineer of this thing. So legally,
right.
that's what you are, right?
Yeah, you're right. You're absolutely right.
So
it's all title.
that's the difference. It's all just a matter of framing it properly. When you're just the handful of guys talking on the YouTube live, whatever.
I just want to be a janitor. Okay. Just want to clean this shit up.
Listen, if that ever happened, please give me a title, but allow me to make that title up, because it's going to be the funniest thing anybody's ever heard of in their life.
There you go.
Oh man, I'm gonna get me a Jack T-shirt. I decided. Okay, it better say that I'm a schmuck, and it better have him pointing, saying you're a schmuck. You know what I mean? That's what I want, so that I can wear it every time I come on. You know what I mean?
YERA, schmuck. You're.
Yeah,
Oh man, I love it.
I gotta have that.
Hard K.
Jack the Fringe Slayer. That's what you should have underneath it. Jack the Giant Slayer, Jack the Fringe Slayer.
I'm a schmuck. Jack said so.
Hi, my name is Schmuck.
I love it. Schmuck
Oh,
Yeah.
that's so funny.
We're all a bunch of schmucks.
That's
Yeah.
it.
And
Oh,
so
I'm
what
sure
does
he
that word
laughs.
mean?
He's watching what we're doing. So is a lot of the other crew. You could tell just by the language that they use when they are discussing things. We'll say.
Well, I'll be honest with you. You know what? If he's watching, have Gerald on. He'll speak for all of us, and that's it.
They
Okay.
don't want. They
Then
just
you can call us schmucks.
They don't want to have me on, and they would just do everything they could to debunk what I have, which is fine. But come down, come grab a system. Let me show you in person what it does. Let me do about 50 experiments in front of you. Take the system home and go do experiments on your own. You're going to see what I have. And that's only one coil. Right? Every coil has its own purpose. It's just like there's a place for everything, and everything has its place.
Oh,
That's
yeah.
what they had to do with the thunderstorm generator, unfortunately. Same exact thing.
Yeah.
Because they put it up and everybody was like, no, that's not, no. And they found every reason in the book why it wasn't doing what they were saying it was doing. And then they were showing it. They're like, no, here it is doing it. And they're like, no, but that's not why. And then they were like, okay, fine. We're going to shrink this technology. We're going to bring it around so people could physically see and test with their own instruments and do with their own thing. And then they could say it's magic and trickery and camera tricks all they want, but At the end of the day, like, you're the one that brought the instrument. You're the one that stuck it in there and tested it. Like, what more do you want? It's doing it. You know, and then all of a sudden, then you stop hearing people hate on the thing and just stop talking about it altogether.
Because it's working. Just like Stan Meyer. When it works.
And that's it. Right.
What were you
They don't
gonna
want to talk about it at all anymore. They wanted to talk about it when they didn't think it worked, why it didn't work. Once they realized it worked, it's crickets now. Crickets.
Man, I wish Stan Myers came in the internet age like we are, like could have a YouTube channel and stuff.
Oh,
that'd be awesome, wouldn't it?
I got a few of his basement videos where he talks about his water spark plug and his whole setup. It's like an hour and a half. He's sitting there doing a lecture on a chalkboard in his basement or somebody's basement. He thanks them in the end. So it's interesting. Gives a
That's
whole
cool.
presentation. Yeah. Stan Meyer was a freaking genius, man. That guy had it. He had it. I don't give a shit what any of these physicists say. That guy knew his stuff. And if it wasn't him, it was his brother. And his brother was teaching him how to do it so that he could promote it for his brother. Either way, man, he had it. So, what do you do? But, Victor, we cut you off earlier. Do you remember what you were going to say?
I was going to ask old man if I need to send him any money for my 3D printing.
No, I'll have it done here soon. Yeah, it just takes time with one printer doing it. It's all the same color. Sorry about that. Actually, as a matter of fact, I got boxes over here and packing material, okay, for a printer to go out to Gerald, and then I got one for Ben.
Really?
Yeah, so I got all this stuff over here. Hold on, I'll show you. Oh, big old thing of packing material and some Home Depot boxes and a bunch of printers. So
You were serious. That's awesome.
I wasn't joking, man. I own them, so it's just ship them out.
That's awesome. I appreciate
I have
that.
about as many computers as you've got printers.
Nice. Used to have a lot of computers. I sold a bunch.
Old man, he says what he means and means what he says, you know?
Absolutely. That's what I've seen so far, and I like that. That's old school. There's nothing better than old school.
That's right.
Yeah.
Well, if you can send me a PayPal when that's done, I'll send you some cash for shipping and payment and your work.
Yeah, definitely. I'll pay for shipping and all that as well. Yeah.
Okay.
Yeah. That
I'll
way it
let you
doesn't
guys
hurt.
know. I got to go down and swipe my credit card after I package it all. Make sure that it passes packaging. So
Awesome. Yeah. Yeah. PayPal's the way to go on that one, right?
I have no idea.
It's the only app
No.
I'm using right now for sending
Yeah.
money.
I'll
Yeah.
have
Well, you can email it or e-transfer it too.
I have no idea.
Well, you did say that you were old school, didn't you? Well, that just shows it.
What do I know, right?
Oh, I know what you know, Gerald, because I was there when you were trying to get your stuff worked out.
Yeah.
Oh,
I know nothing.
Me either.
so funny.
It's
I'm
like
riding
my
on the
son-
coattails of Nathan here for conversation.
There you go. Well, we've been on for 4 hours.
Yeah, I was gonna say it's getting close to the end, guys.
Yeah.
This is-
Time always flies.
Wrap
That's the
up.
truth.
You were talking about names there, and my son asked me, he says, "You used to fight when you were younger, right?" And I was like, "Yeah, I trained heavy. It was extreme martial arts." And he's like, "Did you used to say something cool to people before you fought?" And I went, "No, not really. They'd ask me who I was, and I just told them I'm nobody." And he went, "Like the movie?" I was like, no, not like the movie. Not Mr. Nobody. Did you guys see
Wow.
that movie? It's pretty good.
I used to do backyard wrestling when in high school.
Oh, yeah?
We built a 40 by 40 ring in somebody's backyard,
Dang.
and all old school, man. And I made all the belts out of Mylar, Okay, the whole thing, the look, craftsman, you know what I mean, kind of thing. You used to get out there and wrestle all the time, and then do the drops and everything. It was awesome. Okay, I also trained as a boxer, so the big forehead, yeah, I got hit about 1,000,000 times. So, yeah,
That's
And
a
that's
kid
some
that
that's some
big forehead.
real deal friggin' redneck shit right there, Nathan.
Yeah.
With the backyard ring. Yeah.
Yeah.
Oh, yeah.
nothing wrong with that.
wore my singlet and everything, like Kurt Hennig did. Yeah, I
Yeah.
had long hair like Joe, except for it
Dang.
went down to here about that time.
See, you could have used your forehead for headbutts.
So here's what's funny about this. If I put it up, it's like one big spike as long as my arms.
Dang.
Yeah, I know.
Yeah, you know what the funniest part is? It was cut just like Joe's too. Absolutely
Really,
nothing on the sides, nothing in the back, just the hair on top.
That's it.
Wow. I had a mullet. That's about as far as I can go with that. Had it but hung down to about here, right? It was curly. Now I'm going bald on top. Pretty soon I'll just shave it, keep it shaved.
That's right. Have me a Captain Picard look.
Yeah. That's it. Bick it.
But just in the center so I can keep the old man look. So I just cut it that way in the back and leave the sides.
There you go.
You know what's funny? When my daughter was born, she had hair all around the sides and all on the back, but nothing on the top. So I was joking. I was like, you know what? I think I'm just going to cut it off and give it to her. She looked like a weird uncle for a little while, you know? I mean, she's still adorable, don't get me wrong, but definitely a weird uncle look for a little bit.
That's funny.
She's doing good now, though. She got a little, you know,
That's cool.
pigtail things.
Gee, that's so funny.
Victor doesn't want to talk about his hair.
Oh, mine's been through a lot of stages.
Yeah. No
That
doubt.
mohawk once. Ain't proud of it.
You look like you had long hair at one point.
Oh, yeah.
Yeah.
There's definitely long hair aura all over you, Victor.
Yeah, it just gets to be a hassle washing after a while.
And brushing.
Mm. Yeah, it keeps on coming, like, you know, it comes out when I brush it, but it never, like, you know, I'm not losing it. So, a lot of hair. I don't know. It grows back.
Nathan, you know we're all mentally tired when we're talking about hair at the fourth hour.
There you go. I got something to close it out on, okay? Here's what I look like when I was 17 years old.
Uh-oh. Oh, wow.
Yeah, I wouldn't have guessed that.
No, me neither.
You
No,
wore a
you're
tie?
an intellectual.
Yeah, you definitely do.
I wore a tie for a long time, man. I won't wear one now. Yeah, used to be a manager for a long time.
Oh, there you go.
So
There you go.
I'll tell you what though. Let that go to show. You know, the older a man gets, the better looking he becomes, and that must kill women, man.
Men age like fine wine. Women, some age a little differently than that, we'll say.
They have wine with dinner.
Are you saying that they age like wine with the cork off? That's not nice.
Never
Wow.
said that. I said different.
That's not nice. I love my woman. That's that.
Oh yeah, hey, I'm not saying anything's wrong with that. I'm just saying.
all right, guys, before we get in trouble from our wives, I think
Yeah.
it's time to call it quit. Because we're all getting it.
Oh yeah.
Will be.
Not in the right way.
That mine doesn't watch. Thankfully.
You're sleeping on the couch.
That's right.
Yeah.
All right, guys, I just want to thank everybody for being here. Guys, you got something coming up or anything?
Start with Victor, maybe.
Yep, still working on that math deal. I'm going to show the thing I believe is like the pressure gradient.
Yep.
And the two fractal sets then that would lead to it focusing.
Yep. Nice. And Joe, you got anything coming up?
No, not so much, but I'm gonna get with Victor probably between now and next week, and I want to talk about that nickel spin glass and kind of get a little bit dirty with that sort of stuff because I got to be real. As far as material science stuff goes, all these spin liquids and spin glasses and metallic glasses and stuff like that, they would blow your mind what it does without any sort of, any sort of input or anything, just what they are at the molecular level. So I want to dive a little further into that with him and, probably get enough together to have a talk about that. Yeah.
Interesting.
Very cool. What
Um,
about you, Gerald?
me,
There's a
I've
lot of
got.
quasi-crystals in that.
What was that, Victor?
There's a lot of fractal work too in spin glasses and quasi crystals.
Mm-hmm.
Nice.
Very cool.
Nice. And me, I've finally figured out how to do a 3-dimensional globe. I'm finishing that off. I'll display it on my presentation on the 19th.
That's next weekend on Sunday.
Yep.
I'm blocking my calendar, Gerald.
Yeah, so am I. Marking it. So, Todd,
It's not that big a deal. You guys will probably fall asleep during it. What do you mean? Come
yeah, I
on.
doubt that. You're gonna get 500 questions from the whole.
Forget about
Yeah.
it. You know what I'm saying?
Yeah.
It'll be electrifying.
Forget
So-
it.
Yeah. Well, I've been
Yeah,
shocked
I'm gonna
about-
see what Todd's doing and what time he wants to do things, but I plan to have a very entertaining conversation with him tomorrow. He's gonna
Oh, yeah,
present
you're
his
doing that?
paper. Yeah. So he said it earlier in the chat. Yeah. So
Awesome.
I look forward to it, man. It should be a completely entertaining conversation. It has to do with gravity and stuff like that, and absolutely awesome. And
Should be
I think
good.
I think it's gonna be really good. To be honest with you, I've been looking forward to it. It'll be the first time I talk to him live. You know what I mean?
Yeah, he's a smart man. I don't necessarily agree with everything he says, but I don't expect him to agree with everything I say either. We agree to disagree. That's what people do, right?
Yeah.
But that's awesome. That's awesome. He's coming on. Great.
What time will
I
that
look
be?
forward to watching.
Well, I'm gonna probably start normal around 10, and if he's available, then we'll have him right away. And if he has to take something for his family life or whatever, you know what I mean, I'll just let you guys know. But that's the time I usually start. So
Tomorrow.
I'll ask him when I get done here. You know what I mean?
Yeah.
So, but I
Looking
think that's
forward
going to be really awesome because it's, you know what I mean? We're on the fringe. He's on the other side. We're completely schooled and everything. So I got a lot of questions that we have that I'd like to ask and see what the answers is as well, along with, doing his paper and everything.
Yeah. Yeah.
So anyway,
Awesome.
all right, guys. Thank you very much. Thank you, everybody in the
great day.
chat. We really appreciate you guys.
Can't wait to read those comments, people. Catch you later next week.
Right on.
Have a great one.